Good morning, ladies and gentlemen. First of all, you're all very welcome here for our dairy and our dairy beef conference this morning. 2024, I suppose, started off as a very challenging year for farmers from a weather point of view, and the carryover from 2023 left people in a difficult position after a long winter. But I suppose as the year progressed, and particularly in the second half of the year, I think a recovery was seen from the point of view of grass growth, milk volumes and milk price. So I think it has changed the mood and the views among farmers out there, which was very welcome as well. And I suppose we also saw this year, for the first time, a drop in cow numbers. And I suppose what farmers now are looking at is to try and actually maximise the return that they're getting from the cows that they have available on the farm, and probably using the tools that are available to try and identify the better cows and the more profitable cows to have, and to try and breed and focus on those as they move forward. And that's what the theme of our conference here is this morning. It's Profit through Genetics is our first session, and then we're going to just look at genotyping and having the right cow in the second half of our session here this morning. So first up then this morning, we have Kevin Downing, Senior Development Service and Development Manager with ICBF, and looking at maximising the returns from EBI. So Kevin, the floor.
Okay, thank you, Michael. So good morning, everybody. And yeah, look, the title of my presentation is Maximising Dairy Returns with EBI. So look, as you're all well aware, EBI is a well-proven tool at this stage. But just going to focus and just go back to the basics and just explain the evolution of EBI, how we've progressed over the last 20 years, and also, you know, how it's working on the ground at farm level. Going to just cover the benefits of using AI versus stock bulls. That's one of the key strategies that you have in your arsenal, and also the benefit of using genomic bulls over daughter-proven bulls. So there are two areas that I'm going to focus in. Other areas that are important in terms of maximising returns are sex semen, your dairy beef index, genotyping, on-farm data recording, and also having healthier cows and breeding for healthier cows. And they're going to be covered by speakers after me throughout the session this morning. So kicking off, so look, the evolution of EBI. So look, EBI was introduced back in 2000, and initially it was just milk and fertility. They were the two traits that we had in the EBI. And it wasn't until 2025 that we introduced calving and beef traits into the EBI. So as soon as we had information flowing from the factories, the carcass data, we were able to incorporate the beef element in. So then, over the next, I suppose, 20 years, really, there hasn't been a huge amount of change. The weightings have changed, but we introduced the maintenance trait, the management trait, and the health traits. So health being, I suppose, your lameness and mastitis, cell count, and more recently TB. And the maintenance is the cow live weight of your cows that you're milking, and the management is the milking speed and the temperament of your cows. So hasn't been a huge amount of change. Weightings have changed up and down slightly over those number of years. And it wasn't until 2023 when we introduced carbon into the index. Carbon being, I suppose, really a hot topic now in greenhouse gas emissions, and our requirement to reduce our emissions from agriculture. Then there was a necessity there to include carbon in the index so that we could breed more quickly to reduce down our carbon. And we can do that, and we have been achieving that over the last number of years. Just having it in the index will actually fast track that even more. So looking at the trend over the last 20 odd years, you'll see there the top blue line there is the EBI trend. Okay, and you should be all aware at this stage, for €1 increase in EBI, there's a €2 increase in profit. And that's been proven year in, year out with various trials and profit monitor data that Teagasc would have analysed. So where are we today? We're at €184 nationally. So that's that gain, and that gain over the last 5 years, it's about €11 per year is what we're gaining. So that's about €20 extra profit over the last per year over the last 5 or 6 years. You'll see really it wasn't until the introduction of genomics back in 2009. It wasn't really until 2012, 13 then when the benefits of genomics started to kick in, and that graph has been increasing nearly in a straight line ever since. And you'll see milk and fertility, which is the pink, is the fertility, and the brownish line there is the milk. They're increasing at a very similar rate now, and that's what we want. We want both milk and fertility to be increasing as we move along. And for years it was felt that, oh, well, you couldn't improve fertility while you were improving milk, and that's a lot of the talk back in the early days of EBI, if any of you remember back to those days. But we've proven that you can breed for both high production animals with really good fertility. In terms of the calving, so calving has been improving, you know, I suppose year on year as well, and it's very much growing in a very linear fashion. So we have more, you know, I'd say most of you here would agree, you know, calving difficulty isn't an issue anymore. You know, if you remember back 20, 25, 30 years ago, you know, calving difficulty, it was a completely different cow than what we have today. And now calving difficulty is really at a minimum. Looking at the beef and maintenance sub-indexes, so this is the graph of the beef is the one on the bottom and the maintenance on top. So if you look at the top, so it was slightly increasing, the maintenance, but in the last couple of years, last 3 or 4 years, that line has been trending down a little. So well, I suppose we're breeding, the cow size is just starting to increase again slightly over the last number of years. That's what the genetics is showing there. And in terms of the beef, that continues to decline, albeit at a slower rate over the last couple of years. And that decline over that period, it's about 5 kilos of a difference in each animal that's produced, but also 5 days extra to finish those animals with slightly poor conformation. So we've been breeding a dairy type animal with very little consideration for the beef side of it. And I suppose that'll be discussed later in Ross's presentation, and how we try and address that, and how because we're in the milk business, but we also do need to think of the byproduct, we call it the beef calf that we're selling, and we do need a strategy there for that, and the dairy beef index, which Ross will discuss, will highlight that. The health and maintenance, so again, look, they're pretty much flatlined over the last number of years. No major increase. There was a big increase there in the health sub-index, the green line. The maintenance was, the management trait was increasing, but really hasn't made much gains in that over the last 4 or 5 years. So that's the EBI and where we've come from and where we are today. And I suppose just want to show how EBI is delivering on the ground as well. So what we've done here is we've taken all the co-op data that from your own herds, and it's just for the manufacturing herds we've looked at here. So over 14,000 herds in this analysis. And we broke it down into the bottom 20%, the average figures, and the top 20% of herds on EBI. So the bottom herds are at 117, the average herd was 178, and the top herds were at 231. So you clearly see there, and if we just focus on the difference between the average and the top, the difference there in EBI is €53. So what's that achieving? 442 extra litres of milk, better fat and protein percentages, and 53 kilos more milk solids. Okay, but also the fertility is improving, 16 days better calving interval. So, over 2 weeks better calving interval, and 12% of a difference in 6-week calving rate. With the top herds, calving down 81% of their animals in a 6-week period. So big gains to be made there, as you can see, where the top herds are at versus the average. But also the pleasing thing is that they're doing it with a lower carbon footprint as well, 0.069 kilos lower carbon footprint. So we've also done the same for the higher because you could say that management is a big factor in this, and it has to a certain degree. Absolutely. We're not saying genetics is all that performance. So we looked at the big herds. So we looked at herds over 200 cows. And you'll see there the average herd size there in all those was over about 300 cow herds. And you'll see very similar figures again. Okay, the gains aren't quite as big, okay, but they're still there to be had. 14 kilos more milk solids. So we're assuming that the big herds, they're all, should have fairly good management. So very similar management levels, but again, very good performance. Okay, the euro per cow gain isn't quite as good, but you multiply that across the 300 cows in those herds, you're still up at 27,000 euro plus, so again, big gains to be made here by using higher EBI. So what if analysis, I'll quickly run through this. Just if we could breed from the top 20% of herds, okay, so the top 20%, just bred replacements and transfer them into the bottom 40%, and the bottom 40 do nothing, only buy in their replacements. Not saying it's going to happen, but what if it did? So there'd be 69 kilos of a difference in milk solids, okay, but there'd be 24 of that would come from genetics. If we assume, we'll say 35% of it would come from genetics. That would mean the bottom herds would automatically go up to 412 kilos of milk solids. So they have no change in management, just the genetics alone would achieve that for them, which would be equivalent of that number of solids in the herd. So if you multiply that by 650 kilos or 650 euro per kilo of milk solids, that's the equivalent of over 12,000 euro, nearly 13,000 for those smaller or those lower EBI herds. So if you multiply that out nationally, it's big figures, 57 million. So not sure how it's going to happen, but if we could achieve that, if we could get the top herds generating the genetics and putting them into the bottom herds, it would make huge difference to our national meat pool. The areas I'm focusing on, so stock bull versus AI, quickly run through this. I'm sure a lot of you are using AI anyway, but there's still 30% of our replacements coming from stock bulls. And you'll see the bottom line is the stock bull EBIs over time, 204 euros where the stock bull is at today, the average stock bull, compared to AI at 271. That's the progeny from those animals. So there's 67 euro of a difference between AI and stock bulls. So again, you'd have to ask yourself the question, why do we continue using stock bulls when there's so much to be gained from using AI? Looking at the performance of the AI bulls versus stock bulls, you'll see there a difference. There's 25 kilos of a difference in milk solids from the performance of and this is the average of 2022 and 2023, typo there, of the co-op performance data. And the stock bulls are 25 kilos lower. That equates to about 163 euro per cow. So think about that now, every one of your cows. So in your average 100 cow herd, 16,000 euro if you're using the average stock bull compared to the AI. So again, we need to really have a serious think about that. Daughter proven versus genomics, that debate is we constantly hear that. Should I be using genomics? Should I be using daughter proven? Yes, you'll make the gains in the daughter proven, and these are the progeny of daughter proven bulls. On the bottom is the green line. That's the EBI of them over time. The GS bulls, the genomic bulls, are the purple, and the blue at the top is the G1, the Gene Ireland bulls essentially. So you'll see there, there's over 60 euro of a difference between the Gene Ireland bulls versus the daughter proven bulls. So again, yes, you can make gains, but you're going to make far higher gains if you're using young genomic sires. Okay. Looking at the usage of young genomic versus daughter proven, we're still at about 33% of the replacements are bred to the daughter proven bulls. So, when you can see the gains that can be made there from using GS, you just, again, maybe have to ask yourself the question, should I be using more GS bulls? It's remained pretty much static, and there's big returns to be had there. You'll see there the difference between the active bull list. There's the current active bull list the top 20 daughter-proven versus the top 20 genomic bulls. There's €27 of a difference there in EBI. Okay, so that's about 2 to 3 years worth of genetic gain. So again, genomic EBI bulls, they have higher EBIs and they produce more profitable progeny, as we would have seen. So my take-home message, okay, EBI is delivering on the ground at farm level. You know, the question is, can we go faster? That's really the question. And the tools that we're showing you here today will help us achieve that. So the other areas, and the 2 areas that I specifically covered, was using more AI versus stock bulls. So again, if you're using that stock bull, ask yourself the question, is there an opportunity to use AI, particularly in the heifers? And also using more young genomic sires. So with that, Chairman, I'll hand it back to you.
Just for a point of clarification, Kevin, for a bull to become daughter proven, sorry, how long are we talking about?
So the bulls you see on the active bull list today, they're actually, if they're in the top 75, you can be guaranteed they're only proven for calving and for milk. They haven't a fertility proof. Really, to have a fertility proof, you're looking at 8 or 9 years. The bull would have to be on that list as daughter proven to have a fertility proof. So the point is that, yeah, they might have a fairly good milk proof, but their fertility is quite likely to change when they actually have daughters on the ground. So it's one that farmers, I suppose, you know, they see daughter proven and they probably think that it's proven for everything. Generally, it's just those 2 traits, Michael.
Okay. Thanks, Kevin. Next up, we have Professor Donagh Berry. Donagh's head of Vista Milk and Genetics with Teagasc, and his paper is looking at breeding realities, why we don't always get what we expect. So, Donagh, the floor is yours.
Okay. Thanks, Michael. And I guess some of you probably often heard me say breed the best with the best and hope for the best. And that's really what my talk is about, because you don't get what you expect, and it annoys a lot of people, but I'm going to show you some of the biology behind that and why that actually is happening. But before I go forward, unfortunately, I'm going to have to go back to secondary school. This will probably send the shivers down some of your spines, mitosis and meiosis, remember that? So this is the crux of what I'm talking about. So everybody here, we have 2 sets of DNA in all of our cells. We have around 30 trillion cells in our body. Half of that DNA, it's in chromosomes, they came from your father, and half of them came from your mother. So in this situation, the red is from your father. I'm only showing 2 chromosomes out of the 26, just to illustrate the point. And then if you remember mitosis and meiosis, what happens is those chromosomes unravel and they join up beside each other. So chromosome 1 from the father lies beside chromosome 1 from the mother. And what often happens is some of the DNA actually flicks across. So the father and the mother's DNA actually swap. And this is all happening within your cells just before you produce sperm or you produce eggs. You have this crossing over. So you can see the different colors of the red and the blue. And then the DNA halves, and that's what produces the sperm or the egg. So those 4 cells at the bottom, they're your egg cells for the case of females, or your sperm cells for the case of males. Now I want 2 main points to take from this. First is they're all variable. They're completely different to each other, and it is purely random. And the second and the important point is that the average of those is the same as the parents. So don't leave this talk away with, oh, EBI and breeding is just pure random. The average of those sperms is the same as the average of the parents. So the high EBI bulls and cows, when mated together, on average, will produce high EBI progeny, but it's a guessing game as to the variability that actually exists. So let's look at it another way. This is true data. This is the EBI, the sperm of the EBI of a bull of €300. Look at the variability. Hopefully you can see the numbers in the back. On average, those sperm have an EBI of 300. 66% of those individual sperm cells lie within plus or minus €70 of that €300. You think about that another way, 34% of them don't. So 34% of those sperm vary a lot compared to the EBI of the bull. And reliability of the bull has no impact on this. I've got 3 daughters. My variability in my sperm today is exactly the same variability as it was 10 years ago when I had no progeny. It doesn't change over time. Now, this is where the problem, or the opposite of a problem, could exist. 1% of those sperm have an EBI of 136 euros or less. What happens if that sperm is the one that fertilizes the egg? You have a pretty crap calf. 1% of the sperm also have an EBI which is greater than 464 euros. What happens if that sperm fertilizes the egg? You've got an AI bull. Problem is, you don't know which sperm is going to fertilize the egg when you put that semen straw in. And you might look at that and say 1%, sure, that's nothing. That's 77 million sperm per ejaculate has an EBI less than 136. Of course, in the era of equality, diversity and inclusion, we have to think about the female. Female is exactly the same thing. Eggs are exactly the same as sperm. Here we have a 200 EBI cow. Look at the variability in her eggs. She's got 1% of her eggs has an EBI of 36 euros. One of them, or sorry, another one, 1% of them, have an EBI of 364 euros or greater. Again, 36 euros, you don't know which egg is being left off the time that the semen is going in, the time that she ovulated. You cannot know. You cannot predict this. Okay, on average, though, those eggs are 200 euros EBI. So let's look at it another way. This is the same bull, 300 euros EBI. Look at the variability that exists in his sperm. This is exactly what I showed you. Some of them are less than 100. Some of them are greater than 500. We've got the female on the same side, an EBI of 200. Now, in the absence of any information, and this is 100% right, ICBF and ourselves will assume that the progeny have an EBI of 250. And on average, they will. But the problem is this, is the variability. Now, you might look at that and say, this is absolutely crazy. This is the fundamentals of genetic gain. Look at on the right-hand side. If you have the sperm that is on the far right of the blue mated with the egg on the far right of the red, you can end up with an EBI of a bull of 500 euros from mating 200 euro cow to a 300 euro bull. That's your next top bull on the active bull list. That is genetic gain. To date, nobody has rang me giving out about that. They all ring me about the ones on the left-hand side. Right? So would you believe, and I know you wouldn't, if I told you that you could mate a 200 euro EBI cow with a 300 EBI bull and end up with a negative EBI calf? The chances of that happening are less than 0.5%. But with 1.6 million dairy cows in Ireland, that's still a few cows. And all it really takes is one letter to the dealer or anything like that, and the whole thing gets poo-pooed. But that is reality, and you cannot predict it. And you might say to me, Gratz Granberry, you're great with your theory and theoretical science and all that. There's a few grey heads like myself in the audience, few that have lost their grey heads. You might remember these bulls. Edison, Addison, and Edison Slogan. Do you remember them? 2 Dutch bulls, full brothers, exactly the same parents. Look at their differences in EBI. They're differing in calving interval by 9 days. Completely different bulls, despite the fact that they are actually full sibs. So in practical terms, this certainly does happen. And that's what leads me to the second part of my talk. I have an Excel file available if you want it. I can do all these calculations. You can tease around with it yourselves, so just email me and no problem giving it to you. Now, what stemmed this was, with sex semen, I was hearing, you know, maybe we should be selecting the top 30% of our cows and then mating them to sex semen, and that'll be great. So what I'm demonstrating to you here, based on what you've just heard, is it is good, but can we actually do better? So on the vertical is the expected EBI of our heifer calves, based on what percentage of cows of the dams we selected we used the sex semen on. So let's just dig into it a little bit of detail. If we were to select our top 30% of cows on EBI and mate them with sex semen, and forget now drops in pregnancy rates and mortality and wastage, etc., we would end up with a group of heifers that on average are 63 euros higher in EBI compared if we had no selection. So that's really good. Let's go back a few years before sex semen. What could we have done in the same scenario? Well, we would have selected the top 60% of cows, used conventional semen, and got 30 heifers out of that. So what we're clearly seeing here is that, yes, there is an advantage. But with sex semen, we are increasing the EBI, the average EBI of our heifers by around 28 euros. So this is really, really good. However, remember what I've just talked about. We don't know what egg that cow is about to release when she's ovulating. There's no way you can know it. And you don't know the sperm or the bull that's about to fertilize it. No way of knowing that. So what happens if we actually didn't select the dam and instead genotyped the heifer that was born? So we're looking directly at the DNA. We can see exactly what egg was fertilized and exactly what sperm released or fertilized that egg. So if we're to genotype the top, apply no selection to our dams, and I'm not recommending this, okay? But if we were to apply no selection to our dams and just select the top 30% of our heifers, look at the difference in EBI. We're after doubling the EBI from around 60 euros of our heifers up to almost 120 euros for our heifers. And hopefully now you know why. Because we have actually looked directly at the DNA of the heifer. Something, and I can't give a blanket recommendation for this because it's a little bit like what Kevin talked about. If you're a high EBI herd, you might have an advantage of generating surplus heifers, etc. So if you were to look at potentially selecting the top 60% of dams, and then from that, genotyping all the resulting heifers, so top 60% of dams mated with sex semen, from you, for a 100 cow herd, let's pretend you produce around 60 heifers, genotype all of those, select the top 30, then you will result in an EBI of the heifer crop, which is 48 euros higher than if you had just selected the top 30 dams. Okay, so 48 euros higher EBI, that equates to 100 euros more profit per lactation over successive lactations, and of course she will pass that on through her descendants as well. So just to finish it off, it's on a side, it's kind of related, not related, but it also answers a question that I've sometimes being asked, and it's about variability. A lot of farmers asking for homogeneity in their herd. They want a group of animals that are really close in size and milk yield. Bad news is you can't achieve it. Hopefully you've understood that from what I've talked about, but let's dig into it a little bit more detail. Let's go to extremes. Let's pretend you chose one bull with 90% reliability and you made all your cows to that bull. Or you had a team of 20 bulls, unrelated, with a 50% reliability in EBI. We know, right, because this is what reliability tells us, that those bulls can move over time. So in red, you can see that that high reliability bull, even though it's 90% reliability, if it's got a 300 EBI, it can vary by plus or minus 86 as it accumulates more information. The blue distribution, that's your young bulls, your individual young bulls, lower reliability, so they have a greater likelihood of moving to a greater extent. And you can quite clearly see that they can move by plus or minus 193 euros. But that's individually. Of course, if we use a team of bulls, that's a lot tighter. It's down to actually better than the high reliability bull. So that's how the bull can move based on reliability. But now let's look at the sperm. And I've shown you, the sperm is half the DNA. So you can argue automatically that variability that we see has halved. But then you also introduce this randomness of what DNA was in that sperm. So if we look at the variability in the sperm of those two scenarios, we can see it's a lot less. Yes, it is still smaller for the high reliability bull of plus or minus 137 euros. And now the team of bulls is getting a lot closer, of 167. Yeah. Takes two to tango, of course. And you have the female on the other side, also introducing variability, which dilutes the variability of the bull. So let's look at the calf. That's the variability in the calf. If they were all born in a herd from one bull versus 20 unrelated bulls. Yes, there is more variability. There's actually 7% more genetic variability if you use a team of bulls. But it's really small, right? It's 7% genetic variability. But you don't see genetic variability. And we know that all of the differences in milk production, in health, or in height is not due to genetics. So comparing those two scenarios, by using a team of 20 bulls, you actually only end up with 4% more variability in milk yield. You end up with less than 0.5% more variability in health or fertility. And a lot of what I hear a lot of is people want, the same height of the animals, so they're inside the milking parlour, etc. You only see 5% more variability by using 20 bulls compared to one bull. And nobody's really using one bull anyway. They're probably using around 4. So that variability is a lot less. Once you go above 6 or 7 bulls on the right-hand side, you go all the way to 100. That doesn't really affect that component. So my take-home messages are 4 things. Genotyping, it looks directly at the DNA of an animal. That's really good. But from a parental perspective, because it's a DNA that is randomly inherited, it gives you a prediction of the offspring as a group, but not individually. Okay? And this is the point, is the EBI is still really, of the parents, is still really useful in deciding what the expected EBI of the progeny are going to be, but really you have to genotype and look directly at the DNA of the calf itself to determine what DNA is inherited from its sire and what DNA is inherited from its dam. So that's it. Thank you, Michael.
Okay, thanks, Donagh. So really, Donagh, farmers need to be breeding more heifers than they actually need, and then genotyping them to actually maximise the genetic gain that they're going to make on their own individual farms.
Yeah, so the way you phrase that, exactly right. If you want to maximise genetic gain, but of course it's not all about genetic gain. It's about having surplus females and what you do with the surplus females. So it's not as simple as what you're saying, Michael. You can make a blanket recommendation. Kevin's point, if you're in a high EBI herd, you can sell the surplus females. If you're in a low EBI herd, then you're going to end up with non-saleable surplus females. So it has to be bespoke. Excel file is there. We can dig into this a lot better. Dairy beef is the other thing that I think Ross is going to talk about as well. But I would be saying, rule of thumb, maybe selecting the top half of your dams and breeding from those.
Okay, perfect.
And then selecting from within.
We have about 20 seats up the front. If anyone that's standing wants to make their way forward here, up in the front 5 rows, there's about 20 seats there. Okay, next up then we have Bryan Kingston. Bryan works as a senior business analyst on the Herd Plus team in ICBF, and he's going to look at identifying and addressing key areas for genetic improvement in my herd.
Hi, so my name is Bryan Kingston, and I'll be looking at identifying and addressing key areas for genetic improvement in my herd. So some of the areas I'll be looking at will be data recording, so the benefits of recording accurate farm data, identifying your herd's genetics, so using your Herd Plus EBI scorecard report to see where your herd is at, the use of the dairy trend report to see how your herd has progressed over the last number of years, the importance of using a team of bulls equally across your herd to minimise risks, selecting the right females to breed your replacements from, and then bringing it all together using the sire advice application to maximise genetic gain in your herd. So I suppose first of all, look, what has EBI delivered on a national level? This graph shows the rate of genetic gain in EBI over the past 20 years. So if you look at the blue line on the graph, that's the average EBI. And you can see, look, the average EBI for dairy cows this year is coming in at €184. That's €180 greater compared to the cows that were calving down over 20 years ago. And that equates to an extra €360 profit per lactation for the cows calving down today versus the cows that were calving down over 20 years ago. So you can really see the gains that are going to be made over this period. And look, as Kevin mentioned, look, it really wasn't until the launch of the Dairy Gene Ireland programme in 2005 and the introduction of genomic selection in young bulls in 2009 that really accelerated that rate of genetic gain. That's when the milk and fertility really took off. Because you can see earlier on in the years, the fertility, the green line there was slightly declining. But if you look at 2009 onwards then, so the orange line on the graph, the middle subindex, and the green line, the fertility subindex, they both started increasing at the same time and at an equal rate, which is exactly what you want. So I think, look, most farmers will agree that the cows you're milking today is a lot better than the cows you're milking 10 years ago. Look, on-farm data recording is vital for genetic evaluations, recording sires, your calving e-scores, milk recording information, insemination data, they all feed into the evaluations. And I suppose if you think of the ICBF database, it's a bit like a jigsaw puzzle. So the more pieces of the puzzle we have, so the data, the more complete picture the genetic indexes will be. So again, the more accurate you record the information, the more accurate the genetic indexes will be, which in turn help you to make more informed breeding decisions going forward. And look, recording data, look, it can seem like extra work or extra hassle, but really it is a worthwhile investment to sit down and spend the time and to record the information. If we just look at the number of dairy cows there and the count of records on them, so look, out of 1.5 million dairy cows, 84% have a sire recorded, 75% are milk recorded, 71% have an AI serve record, and 70% are AI bred. And now 36% of the national herd is now genotyped, driven there by the National Genotyping Programme. Then if we just zone in then on some of the health traits there, so for mastitis and lameness, look, 14% of cows have a mastitis record, and 11% of cows have a lameness record. And again, look, we would like more records on them to increase the accuracy of the health subindex in the EBI. Don't know where there is a lack of data on some of these low heritable traits, so some of these health traits, the genetic progress is slow. So yeah, we would like more farmers to record more health data because it really is such valuable information. Then if we just look at the last one there, so dairy cow live weight, so 3% of dairy cows have a live weight recorded. And again, look, we would like more dairy cow live weight records to increase the accuracy of the maintenance subindex in the EBI. What we did during the summer in an effort to improve it, we actually undertook a dairy cow weighing project where we weighed actually over 20,000 dairy cows across 105 herds. And look, the results of this project, look, it's increased the maintenance reliability of cows, it's improved the live weight reliability of active AI sires, and it's also helped us to validate the maintenance subindex as well. So yeah, look, we'll be continuing to do more work in that area. But again, look, more health data and more cow live weights are two areas that we would like additional records on. Look, just while I'm on the topic of data recording, look, just to let you know, look, the latest version of the ICBF Herd Plus app is now available to download. Look, you can now view fertility information of animals currently in your herd. You now have the ability to record health and temperament events, and we've also made updated features there to the animal search as well, and a lot of other improvements as well. So look, if you haven't already done so, look, download the new and improved app there today. If you have any trouble, look, call over to the Herd Plus stand, and we can happy to help you out, or if you have any questions or even any suggestions on the app there as well. So I suppose, look, your herd EBI scorecard report, look, this really is the first thing that you need to look at to see where your herd is at. The report will help you, I suppose, to identify your strengths and weaknesses and set your breeding goals. So you can see in the red box there, look, it shows your herd EBI and the different sub-indexes that make it up. It also shows the national average figure and the top 10% figure then as well. And you can use that national top 10% figure as a target for your own herd. And look, again, it ranks herds using a star rating and percentage system. So again, if you're in a 5-star, you're in the top 20% for that trait. If you're a 1-star, you're in the bottom 20% for that trait. So we've just taken an example there of the first herd there, so herd A. You can see, look, it has an EBI there of 170, so it's a 3-star. So it has an average EBI there. But then look, you can see straight away for the milk subindex, it's a 5-star. For the carbon and calving subindex, it's a 4-star. And then look, for the maintenance and management, then it's a 5-star. But then for the fertility, beef and health subindex, it's a 1-star. So look, you can see straight away the areas that this herd could improve on. So then if we take an example of the next herd there, so herd B, this herd also has an EBI of 170. So again, the same herd EBI, but a very different subindex makeup. It's actually almost the opposite scenario there for herd B. So again, you can see, look, for this herd then, it's a 4-star for the fertility subindex, a 4 for the carbon, and a 5 then for the B subindex. But then for this herd, you can see, look, for the milk, calving, management and health subindex, it's a 1-star. So again, look, it's the same herd EBI, but a very different subindex makeup. So look, it really goes to show that not only do you look at the herd EBI figure, you need to look at the different subindexes that make it up when it comes to choosing bulls and to maximise genetic gain in your herd as well. So look, this report will really help you to see where your herd is at and what areas can be improved on. Just to follow this up then with the dairy trend report, this is a really useful report to see how your herd has progressed over the last number of years. Allows you to track your herd performance over a 5-year period across the different KPIs. So you can see there, for example, herd calving interval, your 6-week calving rate, the percentage of your heifers that can calve down at an optimum age, average lactation of cows in your herd. And it also shows your herd's genetic gain there for EBI, milk and fertility. And again, look on this report, you can compare your herd against the national average and the top 10%. So look, a really useful report to see the genetic gain and breeding performance over your herd over the last number of years. So using a team of dairy bulls equally, when you go to select bulls, it's really important that you use a team of bulls equally across your herd, regardless if the bulls are genomic or daughter proven. And that cannot be highlighted enough. Because again, if you overuse on a certain sire and that sire drops or falls in EBI, the genetic merit of the progeny would also be affected. So again, by using a team of bulls, you're minimizing risks. Some bulls will go up, some bulls will go down, but they'll even out and result in a much higher reliable bull team as well. I suppose just around the maximum usage then, I suppose the guidelines is that no more than 15% of mating should be to any one bull. Nationally, 27% of dairy calves in dairy herds are out of one bull. 27%. So look, that is a figure that's too high, and it's certainly an area that we'd like to improve on. Look, based as well on farmer feedback and feedback from discussions group, we've actually developed a bull usage report there outlining the bull team size and guidelines. So this is an example of the report there at the slide. And even if we just look at the top table there on the previous bull team size and usage, you can see, look, the dairy eye bull team usage for this herd was 15, and the percentage of dairy calves born from the most AI bull there was 19%. Then if we look at the middle table, so your dairy eye bull team guidelines, you can see, look, this herd size there is 104, and the minimum AI bulls that this herd should be using there is 8. Then just on the last table there, on the dairy eye bull usage, you can see, look, this herd has used 10 bulls in the herd since mating start date. So look, a really useful report to help you to ensure that you're using a team of bulls equally across the herd. How do you find this report? It's available there as part of the weekly fertility report. So selecting your breeding females. Look, ideally, you should only use females with an EBI of at least 170 for mating to high EBI dairy bulls. And then all remaining females then should be bred to a beef bull with a high beef subindex in the DBI. So breed your high EBI cows to high EBI dairy bulls, and breed your low EBI cows to beef bulls with a high beef subindex in the DBI. Because that approach increases the genetic gain of your milking herd, but also improves the beef merit of dairy beef calves born in your herd. And again, look, maybe if your herd EBI is low or you can't achieve enough replacements with that strategy, consider buying in high EBI genotyped females from high health status herds as well. And look, Donagh touching on it as well, look, genotyping, there's lots of benefits from farmers from genotyping. Look, it can confirm the parentage and increase the EBI accuracy of the animal. Again, look, confirming the parentage is particularly useful if you have a lot of calves born over a short period of time, where it can be difficult to work out what's the correct sire or even what's the correct dam of the animal. At least it'll give you absolute clarity on its parentage. I think, again, look, why genotyping is most beneficial is that if you've surplus heifers, it'll help you to identify what ones to sell and what ones to keep. Because when you genotype a group of animals, there can be a wide variation of results. Some will go up in EBI, some will go down EBI. So really it is one of the best tools to help you identify the best heifers to breed as replacements and to really accelerate that rate of genetic gain in your herd. And look, just on the sire advice then, look, sire advice, it's an online application that allows you to select the bulls that you wish to use for the breeding season and then match them to the most suitable cows in your herd. So look, the program, it aims to maximize EBI, reduce the variation between the milk and fertility subindex, so you have a much more balanced animal on the ground. So for example, if you have a cow that has a low milk subindex, again, it'll match it to a bull that has a high milk subindex as well. Look, there's two ways as well then farmers can run it. They can manually enter bulls or use Sire Advice Plus. So again, manually enter bulls, select your team of bulls, enter them into the application and run it. Sire Advice Plus then, that helps you actually find the bulls by entering a range of traits that you wish to improve in your herd. So for example, maybe you want bulls above a certain milk subindex or maybe bulls above a certain fertility subindex. It helps you find these bulls based on the criteria selected. And look, just to note as well, it also includes a female selector there as well, where again you can mark females for culling, beef mating, selective mating, and so on. So in terms of its usage, around 55% of dairy plus herds are using sire advice. So look, it's certainly an area that we like to improve on and to get more herds using it. There as well, look, research work has shown that herds that use sire advice have lower inbreeding levels than herds that do not use sire advice. So look, it really is one of the best tools there to maximise EBI in your herd in a balanced way. Also help to ensure you're using a team of bulls equally across your herd as well. It's vital for that, and also avoids any inbreeding as well. So I suppose, look, just some of the take-home messages there. Look, if you've not already done so, look, download that Herd Plus app today, or look, call down to the Herd Plus stand there if you need any help, or if you've any suggestions for it. Know your herd strengths and weaknesses. So again, looking at your Herd Plus EBI scorecard report to see where you're at and what areas can be improved on. Select a team of high EBI bulls and use it equally across your herd to minimise risks and not to overuse on any individual sires. And look, finally then, look, use the sire advice tool there to help manage your breeding program there going forward. So that's all for me. Thanks very much.
Okay, thanks, Brian. And last up then in this session, we have Ross Evans. He's a senior geneticist within ICBF researcher, and it's utilisation of the dairy beef index to secure a strong calf market. So, Ross, the floor is yours.
Okay, good morning, everyone. I hope you can hear. Okay, so as Michael said, the focus on this is breeding that beef calf and ensuring that you're able to get a market for that beef calf. If we look at where the industry is trending, you can see there that the herd has expanded quite a lot since 2010 onwards. But you can see that lower blue line there, that we have now reached a tipping point where there's more beef sired calves from the dairy herd than there is dairy sired calves, and that is increasing. It's currently at 52%, and obviously with adoption of sex semen, and herd stabilising, it's going to increase even further. So if we look at the dairy beef index, it was formulated and launched in 2019. So it's relatively still in its infancy. It tries to capture the key components related to usage on a dairy herd. So you have the calving merit there, obviously your calving difficulty, your stochia, gestation, and also mortality or stillbirth. And on the beef merit then, it's all of the traits that are going to impact on the profitability of a buyer who buys those calves, such as the intake, the docility, carcass weight, conformation, the age at slaughter is a big one. Obviously, the in-spec piece, there are bonuses out there for the animal being in spec, but also polled and resistance to TB. And as Kevin mentioned, there is a carbon component in the DBI as well. Okay, if you look at it there on the pie chart, the green made up of calving, about 30%, and then on the beef side, the remaining 60% and the 7% on the carbon. Okay, so I suppose the messages here are, okay, what do you need to know about your herd when you want to use beef sires? So there's a couple of key aspects here. Number one is your calving subindex. Where does the genetics of your herd lie in terms of the ability to calve down that beef calf, but also then the beef subindex. Okay, you want a saleable calf. There's big variation out there in herds in terms of the beef merit on those dairy cows. So you want to focus in and see where you are relative to that. So obviously that herd EBI scorecard will give you the reference of your herd relative to the national average. So I thought I'd dig in here and show you the impact of, we'll say, first of all on the cow side, the calving index that's part of the EBI, and we broke it up there into top 20% down to bottom 20%. We looked at the distribution of calvings and in terms of how they materialised on the ground from the 2024 calving season just gone. Okay, so you can see there that the top 20% of dairy cows have a calving subindex of about 49 euros, and the bottom 20% of a calving subindex there of about 3 euros. Okay, And if you look at then, you have 3 measures then. You have a dairy cow PTA, which is obviously the ability of that cow to calve down, and probably more focused towards the, reflecting the attributes around the size of that calf. You have the dairy cow maternal PTA then, which probably more reflects the pelvic nature of that cow and the ability of that cow to calve. And then you have the other aspect then, which is the sires that were put on those cows. So you can see there that as you go from the top 20% down to the bottom 20%, the dairy cow PTA climbs from 2.3% difficult up to a predicted 3.2% difficult. The maternal goes from about 4.6% to 4.8%, not as much variation there. But, and then the third one then is the profile of the sires used on those cows. Not a huge amount of difference there, 3.1% for the top 20% versus 3.4% for the bottom 20%. And what has happened then, these are the PTAs. Phenotypically then, we can see that those cows in the top 20%, they resulted in 97% normal calving as recorded by farmer. 2.9% had some degree of assistance, that would be a score of 2. And then the 0.4% had a difficulty, a score of 3 or a 4, either a serious pull or a vet assistance. And if you come down then to the bottom, you can see the corresponding metrics on the cows in the bottom 20%. There was 85% of them calved, had a normal calving. 12.5% of needed some assistance, and 2.5% had a difficulty or a vet. So just showing you the consequence of that calving subindex and how it's influencing the degree of assistance on the ground. The calving subindex also includes other traits such as the heifer calving, the gestation and mortality. So it's not all about the direct cow calving here, but just it is interesting to see the difference depending on when you stratify the index. So the next step then is to give you a picture. If we took all the bulls that are reliable out there for usage on dairy cows, okay, and what I've done here is taken all bulls that are 90% reliable for that dairy cow PTA, okay, and looked at their lifetime performance. And if we look at it here, we can see the percentage difficulty, predicted percentage difficulty on the far left. It ranges from 1% up to 10%. You can see the distribution of sires, and these are dairy sires and beef sires. So you can see there that there's about 62% of highly reliable sires have a PTA of 1%. 1100, 2%, 1400, 3%, and then you can see less frequency in terms of the bulls in that are harder calving as you move down there closer to the 10%. And then that's the average number of progeny they have in the evaluation. So they have lots of progeny there, and they are reliable on dairy cows. Now, the next thing then is to look at the level of difficulty / assistance that we see on those. So if you look at the bulls there at the very top, the 1% bulls, we see that they have 94% normal calving, about 5% assistance, and about 1% are difficult, okay? And we move that dial right down to the bottom then, you can see that you're talking about 60%, so 6 out of 10 calves will calve naturally from a 10% calving difficulty bull. 30%, 29-30% will need some degree of assistance, and about 10% will be difficult. Okay, so we do know farmers have a particular value in their head that they can tolerate calving difficulty. So look, you can see there the consequence, the expectation of having to assist as you move through the levels of calving difficulty there. And the final one then, it just gives you an idea of the breeds of the sires. So if you see the first, the percentage dairy sires there, we can say that of the bulls that are 1% difficult, about 84% of them are dairy sires. About 16% of them are Angus. And there's no Hereford or Continental above 90% reliable that's down at 1% calving difficulty. And you can see as you move down along through it then down to the really harder calving ones, they're obviously going to be more towards your continental type breeds. There's no Angus there that we can see that's a 10% calving difficulty. There are a couple of Herefords, and there were a couple of dairy sires, and those dairy sires were older dairy sires going back maybe 20 years ago. And there was a few of them there that were quite hard calving at the time. So look, it gives a picture as to where the calving difficulty expectation is relative to the PTA that's there on the bull. So the message here is for farmers is to decide on what level of assistance you can tolerate in your own herd, and then use that then to actually decide on picking the bulls that you want from a DBI perspective. So the next one then is to move to the current active list. Okay, what's available in terms of active beef AI sires, and we look at the same range in calving difficulty there. We can see that there's quite a lot of bulls there. They're in the 3% up to 5, 6, 7. You'll get some there that are higher at 10%. And then we can see the average DBI alongside them. Okay, so the average for 2% bulls there, you can see there's an average DBI there of 148 euros. And you come down then to the end, you can see that at 10%, those bulls really get hammered on calving difficulty. Okay, there's a really big penalty put in there for hard calving bulls, because we know farmers don't want hard calving. So you can see that the DBI is hit the further down you come on calving difficulty. You can see the average reliability there of that group. They have some progeny. They're not fully proven yet. And you can see the average calving subindex then alongside them. So it'll be higher for the bulls that have less calving difficulty associated with them. If we look at it then in the context of the beef, the range in beef subindex for sires at various levels of calving difficulty here, you can see that as you move up along from 1% all the way up to 10%, there is that negative association between calving and beef. So the more you go for beef merit, the more there's a knock-on consequence in terms of calving difficulty. But there's huge range within any particular group there. So if you look at 3% bulls, 123 active AI sires at 3% calving difficulty, you can see that there's a range. There's an average of 106 euros in beef subindex, but a range from 39 to 175. Okay, and you can see the average carcass weight PTA on the right hand side then as well. So you're gaining going from a 2% bull at 7 kilos of carcass up to 24 kilos for a bull at 5% calving difficulty. So there is a trade-off there as you move. So look, the key messages there is if farmers, if their first and foremost criteria is that calving difficulty, decide what that calving difficulty is, but then look carefully at the range in beef subindex there. There's a lot to be gained from actually from looking carefully at the beef subindex. So this one was just to try and highlight the level of potential change depending on the reliability for a given bull. And I've done this first for Angus here on the left hand side, and basically it shows the reliability along the what we call the x-axis there, going from a 0% reliability bull up to a 99% reliability bull, and the level of potential change in DBI. And this will be an ungenotyped 2023 born male calf, so it could be coming up for sale in the spring. So he has an average reliability there of somewhere around 27%. He can if he was to be put into AI and be fully proven at the end of it, then you could see a range of up to 60 euros up or down, depending on where his initial proof is as to where he ends up. If you buy a genotype male, you can see that level of risk is reduced from about 60 down to 50. It's still there. The average DBI reliability for a young Angus male is still about 45% reliable. Then if you look at the current active AI sires, you'll see that it's up around 70%. You still have a risk of a DBI changing with a bull at a 70%, but that level of risk is less. If you look at the same then for continental sires, the scale there on the left hand side is bigger because there's more variation in those, and there's about 4 or 5 of the main continental breeds in there. So the risk of using a continental sire and the risk of change is slightly bigger due to the fact that there's more variation in that breed for calving and for beef merit. So look, the last aspect, and Bryan touched on it there in terms of sire advice. It is there. It has factored. It now factors in the ability to actually pick your cows for dairy or for beef usage, and it will look to mate the depending on the bulls that you select the cow with the bull in terms of the strengths and weaknesses there. Currently, it's designed that the farmer chooses the sire and the usage rates, but that algorithm does factor in quite specifically the ability of that cow to calve based on her actual current calving subindex. As obviously the farmer can save that to the database and send on. And while Bryan mentioned about 55% of herds, we can see there was about 42% of cows were put through sire advice in 2024. So there's a lot of room there for people to a lot of cows that haven't gone through it yet and potentially would benefit from it. So moving then from when you have used the bull, got the calf on the ground, and moving on to the commercial beef value. Literally the commercial beef value is the DBI minus the calving traits, because the calf is on the ground, he's already expressed those calving traits, you don't need them in there anymore. So you can see there it's the one on the right hand side mainly driven by traits such as carcass weight, conformation, ability to produce in spec, and also age at finish. I suppose the question is, does the CBV work? Well, we done an association. We regularly updated, and we looked at about 62,000 Angus Holstein Friesian steers finished so far in 2024, and looked at the association of their CBV generated last year with the performance on the ground. And if we look at the top 20% versus the bottom 20%, 5v1, so we have about 12,000 animals in both. We can see that the CBV was suggesting about 83 euros of a differential between the top and the bottom 20%. Had a PTA for age of finish about -2 days of a difference in favour of the top 20%, and about 15 kilos predicted difference in carcass weight, but also half a unit of confirmation score as well. In terms of what materialised on the ground, we can see that there was about 26 days differential in favour of the 5-star animals that were killed 26 days earlier. There was about 12 kilos difference in carcass and about a 0.42 of a unit difference in confirmation. Okay. In terms of the price then, we can see that those calves, the 5-star calves were bought for about 215 euros, whereas the 1-star calves were bought for about 170 euros, about a 45 euros difference in price there. In terms of the returns at the factory, it was about an 82 euro difference there. Now, if we also factor in the 26 days age at finish differential, and Teagasc have put that at about €66 days, so €66 for every day longer to finish. That's an additional 43 euros on top of the 82 euros. So look, the CBV, it does work. In terms of aligning your own herd with what you need in terms of a DBI, we put a table here where it shows where the average beef subindex in the EBI is about -5 euros. That means that for you to generate a 4-star CBV calf, you'd need to use a beef bull with a beef subindex in the DBI of about 78. If you want to get a 5-star, that has to be pushed up to 116. If you look at it then, the herds that are the poorest on the beef subindex, the bar has to be set higher there. They need a 90 euro beef subindex from the DBI to get that 4-star calf, or 138 euros to get the 5-star calf. So farmers need to be conscious of where their herd lies in beef subindex when they think about what they need to do to generate that high CBV calf. I suppose where commercial beef value, where can you find it? It is on the online Herd Plus profile, and that will give you CBVs for all animals with a sire recorded. It is also available through the Mart now, but the animal must be genotyped to appear on those Mart boards, and obviously with genotype then you're getting sire and breed verification there. There is a new search facility that's just been launched today. If you look at the ICBF bull search, you will see it. It's called an ICBF Mart tracker, and it allows to go into any individual Mart and screen for animals, and it's not just for CBV, it's for EBI, it's for replacing the terminal on the beef indexes as well, and you'll be able to see the lot numbers there and the CBV and all the indexes related to those animals. So look, that is just being launched today, so it'll be available there for the spring. So it's quite a big development to have that link up flowing. I suppose, look, finally then, there is the financial incentive to use better DBI bulls, launched earlier in the spring, and from what we know, it will be opened again next spring, where you have to use a beef bull that has at least 3-star on dairy beef index, at least 3-star on beef subindex as well. There's a €20 eligible payment there on a maximum of 50 calves. And what we know is there's some co-ops now are starting to consider factoring DBI into their sustainability bonus. So look, it is an area that is it's gaining in importance. So just to summarise, we'd recommend you do use the DBI to identify suitable beef bulls, but know where your tolerance is for level of calving difficulty. That new scheme has been launched to incentivise use of superior bulls. Trading will now be more influenced by the CBV, particularly on the Mart boards, and as more calves are genotyped through NGP. And look, again, the key steps there: know your calving difficulty, know the genetic merit of your cows, and aim to maximise the beef subindex in that DBI. So, thank you.
Okay, thanks, Ross. And if Bryan and Donagh would just come up to the top table here for maybe a few questions. Ross, I suppose there's a little bit more selection needed for farmers when they're picking their DBI bulls from the point of view of getting the balance between the calving and the beef, but also then the older cows, you know, the 3rd, 4th, 5th lactation cows can take that little bit more difficult calving to maximise the CBV calf that will be subsequently born. So there's a bit more work for farmers.
Yeah, and I suppose look, there's definitely a better ability to calve as the cow gets older. So look, I mean the key messages there is to pick a range of bulls, and some that will be suitable to older cows with a higher beef merit in there, and potentially they will have a slightly higher calving merit. But if you know your cows and know what their tolerance is, you will get older cows that haven't got an ability to calve, and you'll get younger cows that do as well. So use the calving subindex as a guide there. It's not a blanket. Older cows will be able to calve these bulls and younger cows won't. There's definitely variation within each of the cohorts.
Thanks, Ross. So we'll just show our appreciation for our panel for the first session, please. And we're just going to move along then. The next section is around genotyping, and 2024 was a big year from ICBF's point of view with the rollout of the NGP, with over 700,000 calves genotyped through NGP this year, and probably another 150 or 60,000 through SCEP. You know, so we're growing the number of calves that are being genotyped on a yearly basis. And I suppose we're just two speakers in this session just going to give us an update on NGP and what's coming available as a result of genotyping cows as well. So first up we have Mark Waters. Mark is a senior business and analyst with Herd Plus, and he's just going to look at the benefits of genotyping and then just an update of where we got to on 2024 NGP.
I was just saying to myself, everything I'm going to talk about has been mentioned about 10 times already this morning, so apologies if I'm repeating the message, but it should sink in. So look, like Donagh, I'm going to go back to basics, just not to assume that everybody knows exactly what genotyping is. It's a word that's been used a lot today and will be used a lot more before you just go home. So when we genotype an animal, we take an actual sample of the animal, usually a hair card or a tissue tag sample, and we analyse over 50,000 individual pieces of DNA in the lab, and then that data is all sent to ICBF to interpret. And the first step that we do then is we check that the correct parentage has been recorded by the farmer. So that's the first real benefit, the first major benefit of genotyping, is to check that that parentage is correct. Parentage errors have a massive impact on the accuracy of our indexes. So all those assumptions that Donagh makes about the average of the progeny are all going to be based on at least half the wrong information if we have a parentage error. So it has a big overall impact, not just on the accuracy of that animal's index, but also the animals that are supposed to be related to them. And of course then, There's the potential, inbreeding has been mentioned a couple of times today already as well. So there's the potential to accidentally inbreed because you think two animals are not related when they are, or unintentional breeding outcomes. So you're trying to breed for one thing and get something else entirely because you're not breeding the two animals that you think you are. So the next stage then is that we calculate a genomic evaluation. So we do this by combining both the genomic data from that DNA sample and the traditional data we have on milk record and fertility on the parents, etc. And this can increase the reliability of our animals' EBI by as much as 30%. And again, it's already been mentioned several times, one of the main benefits of this is particularly with the selection of young stock, whether that's AI sires or stock bulls for use or for the selection of replacements. So it can have a big impact on changing our perspective on which animals are actually best to keep or to sell. I'm going to look at this particular example. This is a real-life example of a group of 48 heifers that were genotyped in a herd. Okay, if we look at the blue dots here, we can see their parental averages from the lowest on the left to the highest on the right. And the red dots then represent what their EBIs were afterwards. Okay, so we can see that quite a number of them have changed there by quite a bit. Okay, so the main point here, again, to drive home that message about the selection is that the group of heifers you would pick from that would have been different, or potentially some different. Many of those would have been passed over if we hadn't been genotyped, and many also would have been selected when maybe they weren't the best to keep. So that's really powerful because it gives us that information way ahead of when we would have to wait in terms of milk recording or fertility records. So with all these benefits included, genotyping has the potential to increase the rate of genetic gain by anywhere from 50 to 100%. And we can see that here, and again, this was in Bryan's graph. We can see that after the introduction of genomics into evaluations in 2009, you can see the sharp increase in the rate of gain, not just in the overall EBI, but in the sub-indexes. Again, these figures are going to be repeated ad nauseum today, but it's well established that every extra euro of EBI equates to around €2 of extra profit in the animal. Ross discussed the dairy beef element and the benefits of genotyping there, so our need to increase the quality of the beef calves off the dairy herd and reduce their age at finishing from a carbon perspective. So the CBV then is a tool designed for purchasers of calves in terms of surety, to increase their surety. So you're looking at a pen of young calves. How do I tell which ones are actually the highest merit calves? So it provides extra surety for buyers to help them pick the highest merit animals. And this in turn then should also reward the breeders of those calves for actually making the decision to use higher beef index bulls. So at the moment it might be hard to actually get the reward for going with those higher beef index bulls. So the CBV should help reward those herds for those good decisions. And look, Ross, in the questions and answers, alluded to some of the other benefits that are constantly being added to genotyping. So traceability is a huge thing. So when we genotype an animal, we can chase them not just to their endpoint in the factory or the milk from leaving the herd, but we can trace the product all the way to the exact animal, right to the consumer. And this has the potential to create a significant point of difference for us in terms of marketing our produce. This traceability also helps us greatly in terms of reducing the impact of those small number of bad actors in there in terms of animal theft or the incorrect disposal of dead animals. Ross alluded to the lethal genetic carriers that we can pick up and avoid matings. And also then we can look at to try and maximise the instances of maybe potentially positive traits such as A2 milk. And then there's other tools, management tools, such as Genocells, which the next speaker, Matthew, will touch on. So what would be to happen if we were to genotype every animal? So effectively all of these benefits would be multiplied if we got to the stage where every animal was genotyped. So Abacus Bio, which are a bioeconomics company in New Zealand, along with Teagasc, did some independent research for ICBF. And their conclusion was that the return on investment for genotyping the entire national herd was as much as 4 to 1. So how do we get from where we are now to having every animal in the country genotyped? Well, that's where the National Genotyping Programme comes in. The National Genotyping Programme, or NGP, was launched in 2023. It's a co-funded programme between the Department of Agriculture, Industry and the farmers. In the first intake of herds, about 10,600 herds joined. There was about 3,800 of those were dairy herds. This level, it's important to acknowledge that this level of uptake wouldn't have been possible without strong support and promotion from Teagasc, private advisors, the milk processors and the farm organisations to get the message out there. So the first thing these herds did was genotype their breeding animals. So by the end of 2023, over 780,000 cows, heifers and stock bulls had been genotyped. This increased the number of genotypes in the ICBF database to over 4 million and led to the single biggest publication of genomic evaluations in January of 2024, with some 620,000 females getting their first genomic eval. It also had the effect of increasing the percentage of the national dairy herd which is genotyped from 6.5% to over 35%. From January then of 2024, these herds were required to take a genotype sample for every calf before they were fully registered. Herds in the NGP have exclusive access to double tissue calf tags. This allows farmers to take both a BVD and a DNA sample from a single calf tag, which helps to reduce the labour of sampling. As I mentioned, the cost was split evenly between the farmer, the Department of Agriculture and Industry. As of the end of November, over 700,000 calves had been genotyped and registered through this system, which is about 35% of all the calves in the country in the same period. And at the peak at the end of February, that meant over 98,000 calves were processed in a single week in the lab. So back to my original point about the impact of parentage. In these herds, a parentage error of some description was found and corrected in almost 17.5% of cases. Specifically, dam errors, which maybe you wouldn't think are as high, were found in calves born in dairy herds in over 7.3% of cases. Incorrect sex was recorded and corrected then in 1.6% of cases. It doesn't sound like much, but when you're talking about 700,000 calves total, 1.6% equates to over 11,000. That's 11,000 animals that maybe we might have only spotted the incorrect sex when we were going to sell the animal and had to go do a blue card change or whatnot. The incorrect breed was recorded in 3.2% of cases. So, for example, maybe where they were put down as Angus and then didn't turn out to be Angus afterwards. Okay, so again, very rarely is this intentional, but it does erode the trust or the surety for the buyer at the end process. And no sire at all was recorded in about 10.6% of cases, but the genotype was able to identify and add a sire in about 80% of these cases. So that's a huge impact in terms of the parentage and making sure that the right data is connected to the right animals in their indexes. Critically, all this was managed within a world-leading turnaround times. Calves were tagged, genotyped, and their passports issued during the peak period on average with just over 12 days. The average from birth to lab was, again, during the peak, about 7 days, but this did creep up all the time over the course of the year as we got out of the busy calving period. It was the single biggest variable in terms of the average, the turnaround times. So we would like to just remind any herds who are partaking in the NGP to make sure and tag your calves regularly and post your samples often to keep this average as low as possible. Look, all those figures sound great, but that's not to disbelieve or make sure we acknowledge that there was herds there who did experience delays at different parts of the process. So, given the extreme time sensitivity of some calves in the springtime, the decision was made not to make a second sample mandatory where the first sample couldn't yield a result or was delayed. This typically happens in about 2% of cases, and this decision was essential in relieving pressure that was caused in the spring by a small proportion of calves at the busiest time of year. We had some issues in terms of samples going astray in the post or delayed in the post, and also inevitably some samples got sent to the wrong lab. So it's important to note that if you send a DNA sample to the BVD lab or vice versa, for logistical reasons, it's very difficult to transfer those samples to the right lab. So it effectively means having to do a retest. So it's important to get that right as much as possible. Despite those few issues, though, the overall feedback for the NGP was very positive. Farmers preferred sampling calves at birth in terms of labour rather than sampling older animals. They were very much like the reassurance of catching their parentage errors and fixing them ahead of the blue card being issued, which cuts down on paperwork after the fact. And increasingly they're becoming to enjoy the benefits of having so much more information so early in the calf's lifetime. We're constantly trying to improve all these processes, though, to make sure that we can keep the system running as smoothly as possible. An example of this is again, as Bryan mentioned, the Herd Plus app. We recommend all herds who are taking part in the NGP download the Herd app so that they can track the progress of their calf samples during the spring. So we reopened the NGP again this year in August of 2024, and we took in a further 4,000 herds, 500 of which were dairy herds, which brings the total number of herds in the NGP to almost 15,000. Across all these herds then we expect to register, genotype and register about 850,000 calves in 2025, which will equate to about 40% of all the calves nationally. So a major step towards genotyping the national herd, but still plenty of work to do. So I will show of hands, is there anybody in the audience who's in NGP? Oh, we have a right few. Excellent. Okay, so just a couple of very quick reminders just in terms of the NGP. So herds would have been, new herds in particular, but even existing herds would have been sent more genotype samples there for cows and heifers that might have been missed the last time round. So we need you to, if you have any of those outstanding, return those as soon as possible. If you haven't ordered your calf tags, make sure you do that as well, so that they're there in plenty of time for the spring. New herds will need an additional button tag, so if you have any leftover tags that are not double tissue tag, you will need a button tag from January to be able to use those tags. And finally, as I mentioned before, please check the samples are in the right envelope, that they're all the same type of sample. Remember, the pink samples, no matter what type of tag you get, the pink samples are DNA, and make sure and use the official NGP return envelope, as it'll help to cut down on postal delays and issues. Okay, so look, the key messages here is genotyping helps maximise our profit and increase our genetic gain, and is key for selection replacements. There's more new technologies coming on board all the time to help increase the value of genotyping. The first season of NGP was a major success and a huge step towards genotyping the national herd. And make sure and get your samples in. Thanks very much.
Okay, thanks, Mark. For just the update on where we are with NGP, and I think it has been a great success, as Mark said. A few hiccups at the start in the spring, but I think once we overcame them, I think it went pretty smoothly. There'll always be some issues, but I think in general, you know, to get to the level of genotyping that we've got, I think has been a major achievement. You know, and hopefully with what's coming on for next year and with TrueSkep as well, we'll be getting to almost 1 million calves will be genotyped. You know, so it's a long way towards getting the herd genotyped, but it's a big hurdle probably to go to the next step. So next up, I'm just going to take Matthew, and then we'll have open to questions if there is any questions. Matthew Thompson is a geneticist with ICBF, and he's just going to update us on a new tool that's for cell count management called Genocells. that will be available commercially next year, and just as to what that can do and how it can help us. Matthew.
Thanks very much, Michael. Good afternoon. Yeah, so as Michael says, I'm going to be discussing a new tool for somatic cell count management called Genocells. So some people might have heard of it, some others might not. So hopefully by the end of the presentation you'll have an idea of what it is, how it works, and maybe how it might be of use to you as dairy farmers into the future. So first I'm just going to start with just giving a brief background. So this is just a snapshot of the current somatic cell count status of milk recording dairy herds. So this was taken just data from the ICBF website this morning or yesterday, a 10-day snapshot. And what it's shown is here in the green bar on the left-hand side, we can see that just 49% of herds have a somatic cell count of 200,000 or less. And this is widely accepted as, you know, the industry standard or target or acceptable level of somatic cells. So I suppose what it's just trying to reflect is that the remaining 51% of milk recording dairy herds have a somatic cell count that it's higher than the target that we're trying to meet. So that's just a bit of background. So why is this important? Why is the somatic cell count, why does it matter? So the first thing, just to remind people that, look, it's a health indicator, so it sort of acts as a warning light for other health. So an elevated somatic cell score may indicate some level of infection, whether it be subclinical mastitis or clinical mastitis. And the opposite end, a low somatic cell count would indicate, you know, a healthy animal or an animal with a healthy udder. The other side of it then, if you look at it, it can be a milk quality indicator. So it's been well shown that, like, the somatic cell count can impact the processability and profitability of the milk. So when you think about it, an elevated somatic cell count can impact the amount of litres or yield produced, but can also impact the rate at which milk breaks down, so that affects the processability and the shelf life. And there's also a lot of hidden costs associated with mastitis. So in both the subclinical and clinical cases, you're going to be looking at possible milk penalties, a drop in the volume of milk. You're looking at antibiotics, veterinary care, labour, and in extreme cases, your cost of culling. So to date, the best practice for monitoring herd cell count would be regular monitoring of the bulk tank for the overall somatic cell count level within a herd. And then once we see a spike, we might milk record to see which individuals maybe contribute to that spike. So that's sort of the current state of play, and maybe you'll see how Genocells can play a role in aiding with this monitoring. So first, what is Genocells? It's a new innovative genomic technology. So it was developed originally by the University of Liège in Belgium. It was taken on by an agricultural consultancy group in France, Synovia, and it's a tool it's powered by genomic data. So as Mark mentioned there's a huge increase in the amount of genomic data that's flowing into our databases, and that's going to continue to rise year on year. So its key feature is essentially it's able to identify high somatic cell count cows within our milking herds. And the license for this technology has been obtained by a partnership of ourselves at ICBF, but also Munster Bovine and Progressive Genetics. So just give a kind of a brief overview or a synopsis of how this technology works. So something we all are aware of, that Genotype provides a unique record of a cow's DNA. Something you might not know is that this unique DNA is also present in the somatic cells of these cows. So when a cow is milked and this milk enters the bulk tank, these cells are in the bulk tank. We can then take a sample from the bulk tank, and if the cows are genotyped, we're able to identify which cows contributed which cells to the bulk sample itself. So that's kind of in essence how this technology works. I'll go into a little bit more detail on how that looks like for you. So essentially, the first step in the process here is calculate, or you take a bulk sample. The total somatic cell count for that bulk sample is calculated. Then using DNA, you're able to align the DNA from the somatic cells to the DNA of the cows, and then from there you're able to calculate a percentage contribution of each cow to the full bulk tank sample. Just things to remember is that, however, in order for this to work, all cows in the bulk tank must be genotyped to accurately map the amount of cells to each cow, and the bulk sample must be collected after one milking following an empty tank. Just to remember that. So how this service will look like for you, the dairy farmer, overall. So the first step, as I said, will be taking a bulk tank sample. So this will be done by you, the farmer. Once that's done, you go onto your app and you declare which cows have contributed milk to the bulk tank. The bulk sample is then posted to the lab where the DNA is extracted from the milk sample and the genotypes are created. They are then sent to ICBF and the genotypes from the somatic cells are matched to the genotypes that we have in our database, and from there then the results are created and we're able to publish the relative contribution of each cow to the bulk tank total bulk tank somatic cell count. So up to this point, there's been a pilot project over the last 2 or 3 years where a fairly comprehensive validation process has taken place with over 85 herds participating. So in this pilot, we looked at various aspects of the process and tried to stress test the Genocells as a service. So the first thing we looked at was obviously the accuracy of Genocells, the adminning and logistical turnaround of providing a service like this, and then the last bit is how best to report the results to the farmer at the end of it. So first things first is just to say that what we found during this pilot was that Genocells was consistently able to identify the highest somatic cell count cows from the bulk samples. The accuracies ranged from around 90% to 98%, and it's again just important to remember that there will be a drop in accuracy if non-genotyped animals are included in the bulk tank sample. For the turnaround times, so that's looking from your bulk sample on farm to when you receive your result from the lab or from ICBF. From farm to lab, it's looking around like on average 2.5 days, and then the average turnaround time in the lab is 4 days. So that's looking at around farm to result in 7 days. So then onto reports and how we report the results to the farmers once this whole process has taken place. So once the Genocells result has come through, the results will be available on the ICBF website or the app. As you see from the screenshots here, to be available from the usual reports section on the website. A report will be generated after each Genocells test, so it'll be dated based on when the Genocell took place. And it's a one-page report that contains all the various aspects of information that you need to act on your treating your high cell count cows. So I'll just touch on a few aspects of what the report shows. I won't go through it all in the interest of time, but look, there's a short summary on the sample itself at the top. But probably what I'm going to highlight here is this section on the right in the red box. This will show the top 10 cows with the highest percentage cellular contribution to the tank somatic cell count. So it has their jumbo number and then the percentage contribution. Down the bottom then, what this section will show, it'll show the results for 10% of the herd, so with a minimum of 10 cows and a maximum of 20 cows being displayed on the report. What it also shows is the Genocells somatic cell banding, and it's just important to remember that the milk recording yields combined with the percentage cellular responsibility are used to calculate this cell count banding. Other features of this is that the animals themselves are color-coded, so red coloured cows would indicate a high probability that their cell count is over the 200,000. Whereas green would indicate below the 200,000 mark. This is another report that will be available. It's sort of a test summary report, and this will only be available once you've completed 4 milk recordings. So once the 4 milk recordings have been completed, this report would then be generated. So some of the features that this report will show that differ to the other one is this lactation status. So for each cow, it will show whether in green if a cow is healthy, in blue if it's recently cured, orange if it's recently infected, or red if it's persistently infected. It'll also show a summary of all the tests to date, so that including your milk recording and your Genocells. It's an order of date, and as I said, this report will be available once the 4 milk recordings have occurred. So just look, the main advantages of Genocells, it's just a really exciting new tool. It complements regular milk recording for monitoring the somatic cell count levels in your genotype herd. The main asset of it, it only requires a single bulk tank sample to get up-to-date somatic cell count information across your milk and herd. It allows the faster identification of mastitis and then obviously the targeted treatment and preventative care. And all in all, look, it will help you to manage your somatic cell count of your herd, which can, as I shown earlier, will can lead to improved milk quality, reduced antibiotic use, and reduction in costs, the various costs associated with mastitis infections. So I suppose I'll just finish with the key take-home messages to remember from this. Genocells enables farmers to identify individual cell counts contributions from cows just through a single bulk tank sample. It's a tool which complements routine milk recordings. It's only available to herds signed up to milk record at least 4 times a year. All cows contributing to a bulk sample must be genotyped in order for this technology to work, and the bulk sample must be collected after 1 milking following an empty tank. And as Michael said at the start there, look, the details on the cost and logistics will be available from your milk recording organisations in the new year. Thank you.
So we're quickly going to just move into our final session, and that's the right cow for the changing policy environment that we have. And I suppose there's a lot of things changing, and conscious of numbers, derogation, various other different things that are putting pressure at farm level on cows and various different things. So it's just 4 presentations, just looking at some of those. First up, we have Stephen Butler. Stephen Butler is a research officer with Teagasc around reproduction, and Stephen's paper is looking at maximising the genetic merit with sex semen, and just an update of where we got to in 2024 and some of the trials there.
Okay, thanks Michael. Okay, so this is a bit of some of this is kind of background information, but also some new data on the most recent performance of sex semen in the field. So go back in time for a little bit first, and we are at a stage where the breeding strategy is changing on many dairy farms. So in this diagram here, or in this cartoon, we've got animals that are being inseminated with conventional dairy semen, conventional beef semen, or sex semen. And historically, the situation was that most females in the herd were eligible for AI with conventional dairy semen. So the first 3 weeks was dominated by conventional dairy semen. In this diagram here, we've got the small animals indicating the maiden heifers, and the larger animals indicating the lactating cows. One of those is colored brown because she was going to get conventional beef semen, an animal you knew you did not want to get a replacement from, but the vast majority are black. They're eligible for conventional dairy AI. And as we move through the breeding season, then maybe the heifers are now running with a natural service beef bull, stock bull, so they're now getting pregnant if they repeat to a beef bull. And as we progress through the breeding season, the same is happening with the cows. So more animals being bred with beef semen. But what happened the following spring was a calf crop that looked like this. So, and these are statistics taken from the Department of Ag AIM statistics over many years. Roughly 27% were female dairy calves. And because we're using conventional semen to achieve those, we're getting roughly 27% male dairy calves as well. And the remainder then are some sort of a beef cross. Depending on, many different breeds contributing here. Could be AI, could be natural service, but that's the makeup. And of course, the female dairy calves most of those are going to go on and become replacements. The beef cross animals can be moved off herd to somebody that wants to raise those, and the male dairy calf is the problem here. And what we're trying to move towards a situation that would look like this. Now there's been a lot of chat already about should farmers be selecting more females for sex semen? Should some farmers be using 0 sex semen and only using beef? But let's think about the situation here where the average farmer wants to generate enough replacements for his or her herd. So in this example here, all of the females, all the maiden heifers are eligible for AI with sex-sorted semen. As a group, they should be the highest EBI animals in the herd, and as a group, they will be the best fertility animals in the herd. And then within the cow herd, we're identifying the best animals. So the best genetically and also the best in terms of predicted fertility. So depending on the herd situation, that might be 40% of the cows, it could be 30% of the cows, it could be more than 50% of the cows. So it depends on the existing EBI on the farm, it depends on how many replacements you need, and it depends on your ability to sell any surplus females that you produce. But equally then, as we move through the breeding season, or even from the start of the breeding season, there's some animals here, some dairy cows that are only going to get beef semen. So you've already identified, I do not want a replacement from this animal. If she's on heat on the first day of the breeding season, she's getting a beef AI. And then when it comes to the repeats, everything's getting beef. The implication of that would be that the following spring, you could still have 27% female dairy calves. That's the question of how many sex semen straws you need to use. But in this example, the proportion of male dairy calves now will be down to about 3%. Now, the 27% is a movable feast here. If you only want 22%, fewer straws. If you want more than 30%, more straws. But the implication here is that the percentage of beef cross calves is going to be markedly increased. And in this example here, it's over 70%. And it's already been mentioned that the dairy herd has already become a bigger supplier of beef than the beef cow herd, and this is only going to accelerate that. Some recent trends in estimated usage of sex semen. So in 2021, that breeding season, that year, there was no sex semen lab in Ireland, so we're relying on imported sex-sorted semen and Irish bulls that had gone on a boat and gone to a sex semen lab in another country. And if you remember back to that time, there was issues with supply, there was availability with the EBI of those bulls, and there was availability with, or issues with only having a very small team of bulls available. But the upshot here is that the overall supply was relatively small. In September 2022, a sex semen lab was opened in Moore Park with a plan to only operate for 3 years to try and kickstart growth in this. And you can see it in 2022 breeding season, there was an increase. By the time the 2023 breeding season rolled around, there was 2 labs in Ireland, the one in Moore Park, plus now one in NCBC in Naas. And you can see that it has been increasing steadily now year on year. So the Moore Park lab closed in September this year, and on the same week, a lab opened in Dovea in Thurles. So we still have 2 labs. There's still adequate capacity to produce as much sex semen as required, but it's up to farmers to grow that demand and usage. What are the implications on the dairy calf crop, the male dairy calf crop? So in 2021, going back to 2020 breeding season, there was relatively small usage of sex-sorted semen. The following spring, 49% of the calves were male, as indicated there in the orange dot, and the total number of male dairy calves, so calves born to a dairy dam, registered as male, 417,000. And gradually then, over the years that followed, more sex-sorted semen was being used, and you can see that the percent of male dairy calves is declining, the total number of male dairy calves is declining. I'm kind of forwarding here what the expected number of projections into the future years here, but you can see that by 2026, we could be down to as few as 250,000 male dairy calves being born. Still a ways to go thereafter, but in a short period of time, a reduction in male dairy calves of about 167,000. Replaced by better economic value beef cross calves. So here's some data from, again, service recorded in the ICBF database. The total AI services is fairly steady at about 1.35, 1.4 million inseminations in total. And over the years, that has evolved where there's a decline in total dairy AI serves and an increase in the total beef AI serves. And right now, they're roughly the same. So here in this picture, this is total dairy AI. And if I just advance here, it's going to show you conventional and sexed. So what's happening here is that there's been a more accelerated reduction in the usage of conventional dairy AI, and it's being replaced by sexed dairy AI. So if we just look at that figure there, 183,000 recorded sex-sorted stems. The total number is more, but this is what's recorded in the ICBF database. So sex semen increasing, more beef AI, this is being facilitated by the sex semen, and this trend is expected to continue. But if we look at in more detail, the pattern of sex semen usage from 2020 to 2024, the orange bar there is the number of herds using sex semen. That has increased from about 1,700 to over 5,000, so a 3-fold increase there. The blue line is indicating the number of sex semen serves, and this is recorded now again, has increased from about 30,000 to about 180,000, so a 6-fold increase there. So more herds using it and more herds using more of it. This is the dairy sire at first insemination for the 2023 breeding season. So what I'm going to show you here is 2023 breeding season data, which is backed up by 2024 calving events. Okay, so we don't yet have calving events for the 2024 breeding season. So if you just look at the pink bars there's 111,000 sex-sorted semen inseminations there, and you can quite clearly see that these are targeted strongly at parity 0 animals, so targeted strongly at the heifer animals. 37% of all the sex semen inseminations recorded were used on heifers. And in total, 80% were between heifers, parity 1, parity 2, and parity 3. So they are being targeted at younger animals, and that is going to be an important part of maximising the benefit there. And if we look at the pattern for conventional dairy semen, you know, there's no consistent pattern here. It's just being used across all the different parities. So this is the pregnancy rate now at first service across all those insemination events. So if we look at the two bars on the left are comparing in blue conventional versus sexed in pink. So the first two are for heifers. So you can see here for conventional AI, conventional dairy AI, 66% pregnancy rate, and for sexed, 61%. Now that is adjusted for the targeting that's going on here. So in terms of relative performance, sex semen is 93% as good as conventional. If we look at the cow population, 57% pregnancy rate for conventional semen and 50% for sexed. So 87% is good. So if we look across cows and heifers, we are talking about sex semen being approximately 90% as good as conventional semen. And you can see here in red here, I'm indicating the number of inseminations that are contributing to that. So very large numbers of inseminations in every one of those boxes, giving us good reliability in those figures. Parity effect on pregnancy per AI at first service, you can see here across all these parities. As we go from parity 0 to parity 5 and older, that sex semen is slightly behind conventional for every single one of these. But note also that the pregnancy per service event is best for the younger animals, and it gradually deteriorates as these animals get older. And that's true for conventional and sexed. So you might be aware of this relationship between heat behavior and timing of AI, and why this is so much more critical for sex semen than it is for conventional. If we know when an animal first shows standing estrus, that first standing mount, we know that 25 to 32 hours later, that animal is going to ovulate. And when she ovulates, the oocyte is released, but that oocyte, or that egg, is only fertile for about 8 to 10 hours. So we need to ensure that there's fertile, viable sperm cells there at the same time. Now, in this example here, if we inseminate that animal 8 hours after that first standing mount, with conventional semen, we know that the sperm cells will be viable for at least 24 hours. So I could slide that insemination time forwards or backwards a little bit, and there's still a really good opportunity to ensure that there will be fertile, viable sperm at the same time as the oocyte is released. The big thing to get into your head when you're inseminating an animal with conventional or with sex-sorted semen is that we know that those cells are, on average, not going to be viable for 24 hours. And this is just a reflection of fewer sperm cells in the straw and the damage that they've been exposed to during the sorting process. And that's where this advice has come from, to inseminate these animals later relative to when that heat first started. So I'm just going to mention here that timed AI overcomes some of this, and we have timed AI protocols that we've assessed for both heifers and cows. They're slightly different. I'm not going to go into them here in the interest of time, but these slides will be included in the publications of the ICBF at the end of this conference. So at the end of all this research and insights from field data, we've come up with advisory messages for dairy farmers. And some of this has already been mentioned this morning. So on the bull side, pick the highest EBI bulls available, use a large team of bulls. You want that for the genetic risk, but you also want it for the fertility risk, because some bulls are going to have a particularly large reduction in fertility after the sorting process. But right now, you don't know who those bulls are. The dams, so in this example here, I'm just saying as a general rule of thumb, the top 50% of the herd based on EBI. That does depend a little bit on your herd EBI. If it's poor, you should be using only beef probably. If it's really high, maybe you want to use more. And then there's rules within the dams, in terms of parity of the cows, days calved, and so on. Should be used in the first 3 weeks of the breeding season, and if you're adopting timed AI, you should use it on the first day of the breeding season. And then, of course, there's advice here on the straw handling on the day of AI. So this is something that we've become attuned to here, that because these sex-sorted straws are more fragile, they need to be handled more carefully. So to conclude then, Sexing Technologies Laboratories in Ireland started in Moore Park in September 2021. That is now closed, but there are 2 operating, NCBC and NACE, and Dove and Thurles, and these have facilitated a rapid growth in the uptake and usage of sex semen in Ireland. It's a key technology for the Irish dairy industry, but we need to be aware always that it is a fragile product. There's absolutely no part of the sorting process that's beneficial for sperm cells, so it requires more careful use. It will deliver fewer male dairy calves, better EBI replacement heifers because you're breeding from the best, better DBI non-replacement calves, so you're going to use more beef semen, and you can select bulls with better beef indexes to achieve that, and improve the overall sustainability metrics. And just a note of caution here, if you're going to use sex semen, if you've never used it, you need to have that conversation with your AI company early. There's no point thinking about this on the 15th of April, because it takes months to sort the cells. The labs are operating 24 hours a day. all the way since last summer to create the demand for sex semen in April and May 2025. So that intent to use it should be registered earlier. And a good rule of thumb here is that for every heifer you require, use 2 sex semen straws. Okay, with that, I'll hand it back to the chair. Thank you, Michael.
Okay, thanks, Stephen. We'll just move along and we'll go through the 4 presentations and then we'll have a session for questions and answers. The next one is one, I think, Siobhan Ring, she's a senior geneticist with ICBF, and it's the enhancing farm resistance to TB, and I think it's one that a lot of questions are circulating around at the moment. We've seen TB incidents right around the country increasing. There's a lot of concern over, and I think people are looking at what are the options they have available. So Siobhan is going to take us through a presentation of just looking at the role genetics has to play in TB. Okay. Thanks, Siobhan.
Thanks, Michael. Okay. Perfect. So look, first graph I'm going to bring up here, it's a graph you might be familiar with from the Department of Agriculture. So I suppose, as you're aware, the situation with bovine tuberculosis is worsening and has been doing so since 2016. So by the end of December last year, we had 5,000 herds locked up during that time period. And at the start of November this year, we had an additional 900 herds on top of that 5,000 already locked up, with another 2 years of data still to go collecting that. So what's even more concerning, it's not just more herds are being locked up, but it's more animals within a herd are being locked up, so a higher percentage of animals are testing positive. So I suppose, why are we here in a breeding conference talking about TB? So look, we're all familiar, I suppose, with the standard measures of biosecurity, wildlife management. These are all important, but them alone are not going to, I suppose, solve the situation. So there's something that you can do right now at the breeding season right inside your farm gate that is absolutely cost neutral, that can help you to combat your risk, I suppose, of having TB within your herd. So how is that possible? So that's what we're going to go through today. So this is just an example, I suppose, of a bit of work I did a couple of years ago on looking, I suppose, to see was there a genetic variability in breeding for TB resistance. So I suppose the first thing to look at, I suppose, is this here is the distribution of TB in various different sires who had a lot of progeny in restricted herds. So on average, this green bar here represents that on average about 8% of a bull's progeny become TB reactors when those animals are exposed to the relevant bacteria. But what we also see is that there are some sires that produce no or fewer than 5% of TB-infected progeny, even within infected herds, whereas there are some bulls where up to 40% of their progeny test positive as TB reactors. So what this shows us, I suppose, is that some sires are more genetically predisposed to having, more TB-resistant offspring, while others are not. So today we are actually able to identify those sires. Since 2019, there's breeding values available for looking for more TB-resistant sires. So I suppose the question that we're always asked is, well, does it work? Can we actually breed for more TB-resistant sires? So this is, I suppose the breeding values have been validated time and time again under various different methods. This is just one example I'm going to show you here. So here what we have is we have 150,000 baby calves, so similar to the calves that Mark would have spoke about, be genotyped, 7, 10 days of age. And at that point in time, those animals would have got their breeding value for TB, the same as they would have got an EBI or whatever it is for each individual trait. So at that point in time, those animals are categorised based on their TB genetic merit of being high or low risk for becoming TB reactors. Those animals were then subsequently followed throughout their lifetime, and they would have obviously had their routine skin tests, and eventually those animals would have been slaughtered. And then what we did is we went back and we saw, okay, well, what was the actual results of those animals? And here what we found, I suppose, is that in this scenario, for the animals that were genetically high risk of becoming TB reactors, those animals had a 26% higher prevalence of TB reactors than those animals that were categorised as low risk, just based on their genetic merit at a week old. So what it's saying is the animals that are less likely to get TB, they do get less TB. It's not saying they won't get TB, but you know, it means that you'll have a shorter breakdown. If you do have a breakdown, it means you have a less likely chance of having a breakdown in the first place. So to look at the impact, you know, what impact can this actually have on farm? And this is just an example, I suppose, of bull usage in 2023 based on the surveys that were done. So again, all I've done here on the bottom axis is the TB genetic merit. So green for smiley face being good. So these are the best third, I suppose, based on their genetic merit for TB. And in red up here, these are the worst third for simply based on their genetic merit for TB. For the worst third based on their genetic merit, there was 300,000 serves, assuming that we'll have 171,000 calves on the ground as a result of that. We would expect 25,000 reactors over the lifetime of these animals, assuming they're all exposed to the bacterium. However, on the other side, we had a similar number of serves. We expect a similar number of calves on the ground. We would expect 10,000 reactors in that cohort. That's 15,000 reactors in difference, just based on that one simple decision as to which bull did you use on the day. Obviously, we do know, I'm simply talking about TB here, and all of these bulls would have had beneficial characteristics for EBI, milk fertility, whatever it might be. But just looking at the case of TB, you can see the dramatic differences that exist in terms of the number of reactors on the ground. So what does that mean, I suppose, in terms of if you're looking to breed for TB? So the genetic merit for TB, it typically ranges from 1 to 15%. The numbers on the page here don't necessarily matter, but what I'll tell you is the average figure is about 8.5. And if you want to have a better figure than that, if you want to have more resistant animals, it means you need to look for a figure lower than that. So the lower you go, the more preferable it is, the better your chances of securing, I suppose, more animals that are more TB resistant, having less lockdowns within your herd. So again, let's just take a look at, I suppose, of how much better can we actually go. So again, I'm going to keep that same graph here, and I told you that average figure nationally is 8.5%. What that means is about 8.5% of a bull's progeny are expected to become TB reactors if exposed to the bacterium. And last year, there was just under 29,000 reactors in the country. Based on their genetic merit, if we were to extrapolate, if our TB genetic merit worsens nationally, which it could do, that would mean in this example here, I'm saying our 8.5 will go up to 12.5, so deteriorate by 4 percentage units. That means we could have 1.5 times the number of reactors, so that's over 40,000 reactors simply based on that genetic merit worsening. However, if we were to improve our genetic merit for TB by that same mark, so 4 percentage units, we could nearly half the number of reactors from what we had last year. So I suppose that's the power that's available through the breeding technologies. So of course, then obviously the question is, well, why aren't we doing more about this if it's so powerful? Obviously, we know that we're breeding for more than just TB. We're in the business of milk. So this is just an example, I suppose, here. In terms of if we're just to take, I suppose, high EBI calves. So these were high EBI calves that were born last year that would be eligible, I suppose, to be, you know, potentially eligible for AI, eligible to be the sires for the next crop of calves. And simply based on that, I categorise them into 5 groups based on their, again, just their genetic merit for TB. They're already high EBI. Categorise them from best to worst based on their TB genetic merit. And then I was just looking to see, okay, well, is there any trends if we're to breed for more resistance to TB within the high EBI cohort? And for my apologies now to those down the back that can't see the actual figures, but what I'll just tell you is, I suppose, I have the individual sub-indexes brought up here. And what I'm trying to show you, I suppose, is that both for the EBI, milk and fertility sub-index across those 5 cohorts, from best to worst, they're the same. So we're not deteriorating in milk yield, fat yield, protein yield, fertility or anything else when we select for animals that are better on TB. So I suppose the message there, I suppose, is that your TB genetic merit matters, I suppose, outside of the EBI. So selecting on EBI alone is not going to result in you having more superior animals for TB. But also, I suppose you have to be cognizant of, if you were to say, oh sure, if we just let the best, if we just breed from the animals that are best on TB genetic merit, based on this scenario here, you've now said, I'm not going to take the other 80% of sires that could potentially have been the sires of the next generation. And they obviously have good characteristics for other traits. So that's something to be aware of, I suppose, as well. So in summary for me, I suppose, look, breeding for TB is a proactive solution, not reactive. So for example, so the herds that are locked up today, if you start breeding for TB next spring, what that's going to do is it's going to help to future-proof you for the next 5 to 7 years. Because if you think about it, the calves in the ground next spring, they're the heifers that are going to be cows in your herd, 5 to 7 years' time. So that's why I suppose it's to think of it like vaccination from that perspective. Breeding values are available for all animals. So all animals in your herd have that breeding values available and can be downloaded from your ICBF profile. The ICBF, the Herd Plus team are outside the door there, so if you want to go through where to find that, you can do that after the session here, I suppose. If you're buying bulls, that information is on the active bull list, Animal Search, and the AI companies are also showing it on their catalogues. And what I mentioned earlier, the lower, what you're looking for when you're breeding for TB resistance is to reduce that figure on that TB genetic merit. So the average herd is about 8%. The lower you can go, the better, without compromising other traits. And obviously, as we always say, genetics is permanent and cumulative. So the gains that you make in your first year breeding will accumulate year after year, those small little advancements. So that's it for me.
Okay, thanks Siobhan. Moving on, our next speaker then, Stuart Childs is a dairy specialist with Teagasc, and just looking at Stuart's papers, looking at the changes to the organic stocking rates and the impact on breeding decisions, and it comes up in a lot of discussion groups is the type of cow that we should be breeding. So just to get Stuart's views and points on that. Thanks, Stuart.
Thanks, Michael. So I suppose I just acknowledge Joe and Lawrence for the work that they've put into this as well. So just, I suppose, first of all, what kind of a cow do we want? I suppose everybody's looking for that cow that's going to have a longer life, as Donagh has already mentioned. We'll say lasting those 5.5 lactations. The labour efficient cow as well. As herds get bigger, we want less and less effort to put into them and basically to get the same return from them. Healthy animals, Siobhan has just mentioned it from the TB point of view, but all the other elements of health that go with them. Carbon efficiency has been mentioned earlier this morning as well, and how that's such an important trait for us into the future. The CAFA value, obviously Ross has talked about that, and Stephen has highlighted how we go about it. And then the most important thing that people need to take away from this when it comes to breeding, we have to think about the profitability of the animal that we're breeding, because that's the ultimate objective for most people. No matter what people will tell you about how much they love their cows and so forth, if you ain't making money out of it, you're not going to stay at it. So profitability is an important element of it, okay? So just to highlight, people will be more than aware of the changes to the organic stocking rates that we're talking about here. Just going back to the start, I suppose, where we were back at 250 kilos of nitrogen per hectare, and some parts of the country are still at that at the moment, but they will eventually go to 220. We had a cow that had 89 kilos of nitrogen, no matter what level of milk she produced 2 years ago. That meant that you were at a 2.8 cows to the hectare of a stocking rate. If we drop to 220 and keep that cow, it brings us back to 2.47 cows per hectare. Then we brought banding into the equation last year, and 220 came into the equation then this year. So what impact did that have? That has dropped for the middle band cows 2.39 of a stocking rate, and for the cows that are at the very higher levels of output, which ended up in the 106 category, they're down at a 2.08 or 2.1, we'll call it, cows per hectare. So the question, I suppose, that I have to answer today, or I'm trying to answer today, is does this policy decision actually require a change in terms of the direction of breeding for people? And you've all seen this already, so I can fly through it. EBI is increasing. Milk is increasing. That's important to remind people that milk is increasing as well in terms of constituents in particular, I suppose, and fertility is improving. So it's EBI has delivered what it was proposing to deliver at the very outset. In terms of the other traits, they've all been covered, so in the interest of time, I'll keep going, but basically they are improving the deleterious genes are being removed effectively, and the positive direction is being increased year on year, so it's a positive story from that sense. In terms of actually what EBI has delivered, and Kevin has shown you even more up-to-date figures here, I suppose it's important to see that when we look at the range in top 20% versus bottom 20%, that all the key metrics that people talk about breeding for are actually being delivered by EBI. So remember that EBI is delivering. So I've slightly older data here than Kevin. 196 euro EBI versus bottom 98, which is up 20 euro on Kevin's slides there a while ago. Milk yield is highest in that top 20%, so this concept that EBI doesn't breed for milk is blown away by these figures, I think. Obviously, we can understand that there's higher fat and protein coming from those, which because of the higher constituents, then we have higher total solids produced. Cell count, because of improving health, is better. Obviously, there's a management element in that. But the fat and protein then delivers, as coming back to my point about the profitability a while ago, it delivers a better milk price for the litre. So a better price litre, as I've heard people describe it before. And then that calving interval, we want cows calving every 365 days, and higher EBI cows have better calving intervals. And that's critical to actually delivering what people are talking about in terms of the change of direction for breeding, as it's, I'll put that in inverted commas, because the question is, do we need to change that? So we're actually breeding for the type of cow that can deliver yield. The cows that calve every year will actually sell more milk. Obviously, it stands to reason, okay? And then again, coming back to what the lads have already spoken about there, in terms of that carbon efficiency that's associated with it, our higher EBI cows are delivering from a carbon point of view as well. Just a brief refresher, everybody's done a refresher this morning, so just to bring everybody back. A plus B minus C, where A is protein, B is fat, and C is processing cost reduction, and that dictates what you get paid in cent per litre. EBI has been driving the push for A plus B, and this is increasing the price that people receive. We see it every year, and when it really stands out is in difficult years, like maybe the likes of last year, when milk price comes under pressure, that difference between the actual base price being paid and the actual price received by farmers, where farms have put emphasis on their breeding, they're getting paid a better price, and that gives them a bit more resilience in more difficult situations. Breeding to increase the sieve proportion is going to incur costs for you, because it means that there's more money taken from your milk check because you're sending in watery milk, basically. So it's important, I suppose. Einstein came up with the theory that energy cannot be created or destroyed, so it can only change from one farm to the other. So if a cow consumes grass, they have to consume enough of it in order to produce that volume of milk. The A plus B piece isn't free energy, but the C actually requires more energy. So a cow is going to have to eat an awful lot more to produce the litres than they do have to produce the A and the B proportion in terms of fat and protein. And then I used to think that this was a bit tongue-in-cheek, but we have to actually look at the situation. Are we looking to make milk out of money or money out of milk? And that's very important for people in terms of the breeding decisions that they're making. Because like Siobhan has just said, in 5 or 7 years' time, what cows are you going to be milking? If the decisions that you make in the spring of 25 are going to have influence on that in 5 and 7 years' time. I think the important thing to highlight from the EBI point of view, in terms of what it's delivering, this is a slide Joe sent on to me. So basically this is the Johnstown Castle herd, same genetics, different systems. So we have split calving, autumn calving and spring calving. And you can see on the right hand side there, in terms of the actual milk kgs delivered, it's kind of driven by what fuel is put in the tank, basically. So where the cows are on the full grass-based type scenario throughout the summer, or from the spring calving scenario, they're delivering more or less the same fat and protein. They're slightly lower solids because they're just not in terms of the actual feed consumed and so forth, and the push on them to deliver milk, I suppose, is maybe slightly lower. Whereas in the autumn scenario, they have to be fed very hard through the winter period, obviously, to feed them. Our grasses are a cheaper form of feed during the spring period, but we can get more yield out of those. The key thing to take from that is that 7,461 kilos of milk in the autumn herd is coming from the same genetics. Okay, so this theory that we have bred milk out of cows is blown away by this. We can get the milk out of the cows if we put the fuel in the tank effectively. Now, there's a balancing point in that as well, obviously, in terms of finances and profitability. So focus on what delivers the return from you, and they'll be hard to see for people at the back, but the long and the short of it is we have to focus on grass utilised is actually driving the margin per hectare. Good relationship with that. Focusing on output, which is what that talk is in the kind of floating around, is that we need to change our type of cow if the system is changed because of the policy changes. But if you focus on output per cow, there's no relationship with it in terms of margin. Yes, there will be herds. Like Donagh said, there's always one person that will have a good positive experience. There'll be people that will have a negative experience as well. So there are herds out there that are high producing, that are high performance as well. But there are equally high producing herds out there that are losing money as well. So just coming back to a piece of work that Patrick Owing did there recently in relation to discussion groups, and some of you will have been at this event that we had during the summer, comparing high and low margin farms. Basically, what is the difference between high and low margin farms? The orange bar is the one that you want to focus on, and the grey bars in this scenario. So high performance farms, so the top farms, these were farms that were making up on €1,100 a profit even in a difficult year of 2022, versus the lowest farm in the grey bar was actually making €40 per cow of profit in 2022. So the difference comes from gross output. So they have higher gross output in the top 10%, and I'll show you more in relation to that in a minute. And slightly lower cost, not hugely, but slightly lower cost, because there's more of a focus on cost. Because of our variable costs and our fixed costs being lower, total costs are lower. So we have more output and we have lower costs. So that's where the margin is coming from. In terms of the physical performance, just what were we comparing in that scenario? I think, again, it's important to highlight that the milk solids is the difference in reality. I suppose with 511 versus 443. Very important to highlight the concentrate input in both of these groups was the same. So these top 10% of farms delivered 60 to 70 kilos more solids by feeding no more meal. So feeding meal does not generate more solids necessarily. What does drive it is how much grass goes down their throat. Just to explain this variation, I suppose, so the gross output, it didn't just all come from one thing. It came from higher milk solids, as I've shown you on the previous slide there. Grass intake, you've also seen that on the previous slide. The calving date is important. So cows that calve, I've already said it, cows that calve on time have long lactations, they deliver a lot of milk. And better fertility then as well, coming back to the point that was made earlier about lower replacement rates as well. So we get the mature cows into the herd. Mature cows actually deliver more milk, as you will know. And we also get the opportunity to cull out the poor performers as we're going along, so that we have the best cows available to us in any given year. Then I suppose just to highlight on a few points, I suppose lower veterinary costs will say potentially linked to better health was one of the points that came out from the lower costs, and also just lower overhead costs in general. So better cost control as a whole. Now I'm missing a slide here, I think, so I'll have to skip over that. But basically, Lawrence has checked I suppose sometimes there's a fear out there that people think that we don't validate what we're doing here, maybe. So Lawrence has validated the EBI, we'll say, for if we change to a situation where the nitrates kicks in and it does put pressure on us, how does the EBI actually stand up to that challenge? So he's looked at a number of scenarios there, and basically the long and the short of it is the economic valuations that you would use in the EBI don't change, and they're highly correlated. So basically the index that we have currently, if you apply the index in relation to the change for nitrates, it more or less mirrors onto one another, that the current EBI is still fit for purpose. So in summary, Michael, EBI has delivered for Irish farms. You've seen that through the course of all the presentations that have been given today. I suppose it is important to point out, and again it was highlighted earlier in terms of the genetics is delivering a certain amount of it. There is a requirement for management at the other side of it. So just as an example, there was heifer sale here last week. There were heifers sold at this sale last week that are all minus for milk, but they are coming out of a herd that's doing 8,500. So it's not about that having a plus 500 cow for milk, basically. That's breeding the wrong type of cow. Stick to the plan, basically, is what I'm saying. And I suppose the point that I'm also making in relation to the genetics is I can have a Ferrari outside in the car park there, but if I've no fuel in it, I can't get to Fermoy. So you have to feed the animal that you have as well. And that's what the Johnstown slide is showing as well. So, ultimately, and Aidan will be getting nervous now talking about feed here, but basically, we still want to feed them with the right feed. We want a cow that's capable of turning grass into milk. And that actually becomes more important if we become hindered or implicated by nitrates, because we'll have a reduced stocking rate, as you saw on the first or second slide there. That actually means cows have more grass available to them. So they need to be efficient converters of that grass. And then the additional feed is the concentrate, maybe that's needed at different times of the year. They need to be able to use that obviously as well. So the final points, I suppose, Michael, are follow the money, focus on EBI to continue to breed the profitable cows that have been bred down through the last 20 years, and policy changes should not alter your focus in relation to that. Okay?
Okay, thanks, Jordan. That's a great final point, I think, just around policy changes. So last speaker in this session then is Simon Lanigan, a graduate geneticist with us in ICBF. And Simon is just going to look at the genetic evaluation updates for 2025 and just any changes that are coming there. So, Simon.
Thanks, Michael. So, my name is Simon Lanigan, and I'm going to be looking at the genetic evaluation updates that we're hoping to bring in 2025. Before I start, I just think Stuart hit the nail on the head there with that the EBI is delivering for Irish farmers, and that one of those key performance indicators for farms is output. So when we look at that top 20% of herds compared to the national average, they are doing 53 kilos more milk solids, and this is driven by better production and better fertility. But I suppose what we've also seen over the last few years is an increase in the cost of our fertilizers that we're using, the increase in the cost of feed, alongside the milk price that we are getting at the farm gate. And alongside all of this, we are still maintaining a steady flow of data into the ICBF database. So in order for the EBI to keep delivering for you as dairy farmers and as reflective of the cow type within your herd, we have to make some minor readjustments to the EBI in the later end of 2025 so that it keeps delivering. These changes are an economic value change, a base population change, how we calculate our health and our management, and our linear type as well. So just to delve a bit deeper into this, and what does this mean for you as a farmer? Well, Teagasc have done a lot of work in updating the economic values in the EBI index, which reflects the input costs, our output prices, but also look into future market predictions and our processing costs. So if we take a step back for a minute and we look at what we were paying for feed and fertilizer in 2019 versus what we were paying for it this year, well, also our milk price. We were getting 38 cents a litre on average back then, and now we're getting around 50 cents a litre. So we have to account for all of this to make sure that the EBI is that profit index and accurately reflects profit on Irish dairy farms. We are also going to couple this with a base population change. So what exactly is a base population change? It's essentially just a group of animals in the past that we have a lot of data on that we can compare the cows in your herd to. So we set their genetic merit to 0, or their predicted transmission ability, and then we compare our EBI of the cows in your herd to these base population change. So I just took for an example what you would see in a catalogue when you open up, and for the example of this bull, he has in the red box a milk genetic merit, or PTA, of plus 32 kilos of milk. So this means that on average he is expected to pass on to his progeny plus 32 kilos in milk on average. So I suppose, why would we change this? Well, our current base population is based on 2005 born cows, which were calved and milk recorded in 2007. So they're roughly producing 6,000 kilos of milk and have a fat and protein percentage of 3.91 and 3.43. Well, I suppose because we have so much data flowing into our ICBF database, and particularly around NGP and the continual flow of data from you as farmers recording, we want to increase this from 2005 to just be a more reflective cow type of the cows that you have within your herd. Thirdly, we're going to be updating how we calculate our linear type or our conformation traits which we publish on our animal search and our bull lists. So this is in line with Teagasc research that Maeve Williams carried out. So what exactly is linear type? It's essentially an assessment of an animal's physical characteristics. So we score animals on a base of 1 to 9 that can be generally categorized into body size, mammary system, feet and leg conformation. But by making changes to this, we're going to be more accurately reflecting the data that we have, and we're moving towards this international standard of single-step genomic evaluation, alongside updating some of our genetic components, which increases the accuracy of these figures. So if you want to look at the conformation traits of your animals or your bulls that you want to select, you can go on to that animal search or that bull list and select go into the type and look at those figures then that are being presented for that. And then finally, we're going to be making changes to our health and our management. So within the health, we're updating the way we calculate our lameness and our mastitis. So we have new data coming in on locomotion, and we're changing also how we reflect the data that we already have. And again, moving towards that international best standard of practice of single-step genomic evaluation. And then in terms of management, we're just changing how we reflect the temperament within our models. So the current temperament was calculated based on the dairy efficiency program when that was financially incentivized, but that is no longer the case. So we just need to make that reflection within our index. And then adding in our milking duration data from our DIY handhelds, which is already flowing in, but increasing that. And then just a note on the importance of recording data within the app and logging into your Herd Plus screens as well. So it's very important that if you have lameness or mastitis, that you're logging into your app, that you're recording this data, because it's very useful for us and for the EBI then to deliver for you as farmers then going into the future. But I suppose the big final impact of what this means for you. So we're currently seeing a very strong relationship between our current EBI model and our proposed EBI model, but this is still a work in progress with the timeline being around the end of next year. So our linear and our health and management are moving towards that single-step genomic evaluation, and that base and economic change is needed to be more reflective of the markets that we find ourselves in. And then finally, just a note that none of this would be signed off until it goes through our technical advisory group, which consists of international and national experts in the field of animal genetics and the board of ICBF. But we will be hoping towards the end of next year, perhaps, the introduction of these changes. So that's all from me. Thank you.
Thanks, and maybe we'll just show our appreciation just then for the panel then just before we... So the last thing then just before we break for lunch is ICBF has just looked at identifying 100 dairy breeding awards and farmers that have been, I suppose, participate and have good EBIs, EBI gain, milk recording. I think there was 12 different traits that they were looking at, or 12 different KPIs within the herds, and just selecting 100 people just to identify, and then we've narrowed that down then to those 100 will get a plaque in the post, but we've 4 then regional winners that we just want to present here with awards here this morning, and we'll just Aaron is going to. So I suppose it's just to acknowledge those that have been making good particular gains, and just to identify and reward them. So Erin, do you want to?
Yeah, I can do. So yeah, thanks everybody for your patience. I'm sure you're all full of information now and probably quite hungry, so I will keep this short and sweet. So just to conclude, we'd like to recognise all of the very deserving recipients, as Michael has said. I suppose this prestigious award is a testament to your exceptional achievements in both cattle breeding and sustainable farming practices, areas that are vital for the future of the dairy industry. And look, the work that you're doing plays a crucial role in ensuring the long-term sustainability of the dairy sector in Ireland, and we commend you for your efforts there. So look, it's a great pleasure that I get to announce the overall winner for each province. So what we'll do is I'll call the names out, and if the winners could hold back afterwards, just want to get some photographs and things like that, but everybody else can go out and get a cup of tea and something to eat. All right. So we'll start with Munster, and the winner of the overall award for Munster is John William Dwyer. So round of applause, please, for John Dwyer. So very briefly, John is currently milking a herd of 187 cows in Cashel in County Tipperary. John has been an active participant in the Gene Ireland programme for over 10 years and has seen a very steady increase in his herd's genetic gain. This herd has been achieving huge gains in EBI, particularly over the last 5 years, and currently sits in the top 2% nationally with an overall EBI of €250. So congratulations, John. So the overall winner then for Leinster is Jamie Keeley. Jamie is currently milking a herd of 96 cows in Rathogan, County Carlow. Jamie has been a user of the ICBF sire advice application for many years. The genetics used in the herd has largely contributed to the increase in overall EBI year on year, and his EBI currently stands at €248. This herd boasts a very impressive crop performance report, placing in the top 1% for kilos of solids per cow. Congratulations. A bit further afield now, and our overall winner for Ulster is Jared McKeown. Jared is currently milking a herd of 68 cows in Dartry in County Monaghan. This herd has been making huge strides in EBI, but particularly the herd's milk and fertility sub-indexes in recent years. The herd EBI is currently at €258, which places Jared in the top 1% nationally. Jared engages in high levels of data recording and is actively involved in the various schemes and programmes available. Huge congratulations. And last but not least, the overall winner for Connacht is Tom Clesham. Tom is currently milking a herd of 51 cows in the Neil in County Mayo. The herd places in the top 5% nationally for overall EBI and in the top 10% on a number of calving and fertility key performance indicators. One of the standout achievements of this herd is Tom's consistently low SEC figure of 50. Year on year, the herd sits in the top 1 to 2% across the co-op for SEC. Congratulations, Tom. So yeah, finally, just on behalf of the ICBF team, I extend our warm congratulations on this well-deserved recognition, and we wish you all ongoing success and look forward to seeing the continued positive impact of your dairy farming in the years ahead. Thank you.